Hello everyone, कैसे हैं आप सब? So I'm really happy that you have joined once again to yet another session on AIATS Plus, right? So this time we're going to be covering the test MT3, right, which was conducted on 24th of January 2026. Okay, and आज जो है we are going to be once again doing just like what we did last time, right? We are going to be going through the questions, discussing some concepts wherever there are some nice concepts to be discussed, and let's solve those questions together. Okay? Okay, so let's begin. All right. So first up is your question number 1, right? So let's read this one. It says the linear momentum P of a particle is given as a function of time t as P is equal to AT square plus BT plus C, right, where A, B and C are constants. The dimensions of C they are asking, right? So this question is based, let's say, on your first chapter of 11th class, units and dimensions, right? And remember the equation of momentum that has been given to you over here, right? So first up, a few basic things, right? That is momentum P. What's its original formula? If you might remember, whatever you have studied in your 11th class, right? If we can write like this, momentum P is given to you as mass into velocity of an object that is having a mass m and moving with a velocity v, right? And what would be its dimensions? So the dimensions of momentum is nothing but the dimensions of m into v, right? That is dimensions of m, that is mass, and dimensions of velocity. Right? The dimensions of mass is pretty simple, right? That is m only, while the dimensions of velocity v is Lt minus 1, right? Why Lt minus 1? Because what is the unit of velocity? That is meter per second. Okay? So this is the dimensions of momentum. Okay, now coming back to the question, they are saying P is equal to AT square plus BT plus C, right? So let's focus on the dimensions of momentum. Let's write it over here, okay? And remember, we have to find the dimensions of C only, okay? And now, if I write that equation once again, P is equal to AT square plus BT plus C, okay? So I can say that the dimensions of momentum is equal to dimensions of AT square is equal to dimensions of BT is equal to dimensions of C, right? Because if you are able to add 3 quantities, that means all those 3 quantities are having the same dimensions, okay? So therefore all 3 are having the same dimensions as momentum, but they are only focusing and asking about C, and just as I have written, C is nothing but having the same dimensions as of momentum, right, which is ml t minus 1, right? So ml t minus 1, as you can clearly see over here, right, it is option 3, isn't it? Yeah, so someone has commented, yes, third option, yes, you are right. Let's check the answer slide as well, right? And yeah, third option is correct. Okay, so someone has said second is correct. No, second option is wrong. All right, why it is wrong, I now told you. And similarly, just as the dimensions of C, we can also calculate dimensions of A also and dimensions of B also. ठीक है? Dimensions of A कैसे निकालेंगे हम? देखिए, if you want I can write it over here itself. ठीक है? Dimensions of A क्या हो जाएगा? Just in case if they had asked, right? So it's nothing but the dimensions of momentum divided by the dimensions of T square, right? But dimensions of T square we already know, that is capital T square, right? So if you want I can directly write capital T square over here. That's it. All right, and similarly if they had asked dimensions of B, what would you have done? That is also same, dimensions of momentum divided by simply T. Okay, so this is how you would have done that question. Okay, so I hope you got it. Let's move on to the next one. Second question, right? It's also a very simple one. Let's read on. It says in uniform circular motion. ठीक है? अच्छा अब देखिए, द मोमेंट यू रीड दिस टर्म यूनिफॉर्म सर्कुलर मोशन, ऑल दोज कंसेप्ट्स दे हैव टू फ्लैश इन योर माइंड, है ना? क्या क्या कंसेप्ट्स अभी बताता हूँ. लेट्स रीड ऑन. स्पीड ऑफ पार्टिकल दे हैव गिवन, ठीक है, 2 मीटर पर सेकेंड. रेडियस ऑफ सर्कल ऑल्सो दे हैव गिवन 2 मीटर. देन द वैल्यू ऑफ सेंट्रीपिटल एंड टेंजेंशियल एक्सेलरेशन आर रेस्पेक्टिवली, ठीक है, टेंजेंशियल एक्सेलरेशन आर रेस्पेक्टिवली. अच्छा, सो व्हाट अबाउट यूनिफॉर्म सर्कुलर मोशन? तो देखिए, फर्स्ट अप व्हाट इज यूनिफॉर्म सर्कुलर मोशन, है ना? सो ऑब्वियसली इट्स मूविंग इन अ सर्कल, दैट मच इज क्लियर, ठीक है. सो सर्कल मतलब एक छोटा सा, लेट्स से हियर इज योर सेंटर, ठीक है. लेट्स कॉल दिस वन एज पॉइंट O, ठीक है. एंड लेट्स से द पार्टिकल इज मूविंग ऑन द सर्कमफ्रेंस, ठीक है. सो लेट्स से द पार्टिकल इज ओवर हियर, दिस इज द पार्टिकल, इट्स मूविंग लाइक दिस, ठीक है. एंड हाउ इज इट मूविंग? तो ध्यान रखिए, जो उसकी जो स्पीड है, और rather the velocity is tangential to the circular path, all right. So it's like this, that is your velocity v, ठीक है. और when we call it uniform circular motion, तो that means ये जो speed v है that is constant, ठीक है. तो ये आपको ध्यान रखना है. So uniform circular motion में number 1, ठीक है ना, ये जो speed है that is constant. But remember, speed is constant, the velocity is not constant. ऐसा क्यों? क्योंकि velocity meaning magnitude is also there, direction is also there, है ना. लेकिन हर point पे direction अलग अलग है, right? Here the direction will be something like this, उसी speed v का, और here the direction will be something like this. So direction is different, that means velocity is different, but speed will be constant, ठीक है. अच्छा, एक और चीज़, जो centripetal acceleration है वो क्या होगा? Centripetal acceleration, that is AC, is given to you as v square by r, है ना. और radius जो है path का, that is not changing. So centripetal acceleration v square by r, उसकी भी क्या constant है? Only magnitude, है ना. But centripetal acceleration is not constant, its magnitude is constant, ठीक है. तो इसको भी हम बोल सकते हैं constant है, all right. Okay, and then third, that is the tangential acceleration, है ना. अच्छा, टेंजेंशियल एक्सेलरेशन क्या, हाउ इज इट गिवन बाय? उसकी मैग्नीट्यूड जो है वो ध्यान दीजिए. सो इट्स मैग्नीट्यूड इज गिवन टू यू बाय सिंपली dv by dt, ठीक है. याद रहेगा सबको, dv by dt, है ना. बट जस्ट नाउ आई सेड ये v क्या है यहाँ पर? स्पीड, लेकिन स्पीड तो कांस्टेंट है. सो देयरफॉर dv by dt भी 0 हो जाएगा, है ना, बिकॉज इट्स डिफरेंशिएशन विल बिकम 0. सो टेंजेंशियल एक्सेलरेशन इज 0 फॉर यूनिफॉर्म सर्कुलर मोशन, ठीक है. अच्छा, नाउ व्हाट इज इट्स डायरेक्शन? यहां पर कैसे हम बताएंगे? देखिए, सेंट्रीपिटल एक्सेलरेशन इज गिवन टू यू लाइक दिस, ओके. इट्स टुवर्ड्स द सेंटर ऑफ सर्कल, तो ये मैं बोलूंगा इसको AC, ओके. टेंजेंशियल एक्सेलरेशन तो कुछ है नहीं, ऑलराइट. नाउ लेट्स से इफ इट वर नॉन यूनिफॉर्म सर्कुलर मोशन, है ना, that is non-uniform circular motion, है ना. तो ये याद रखना भी आसान है. हाउ? क्योंकि इसमें जो स्पीड हो जाएगा that won't be constant, right? So speed, it's either gonna increase or decrease. It's gonna increase or decrease depending on your tangential acceleration, ठीक है. So speed is not constant, हाँ, इसको मैं ऐसे लिख देता हूँ, इट इज नॉट कांस्टेंट, ठीक है. और जो सेंट्रीपिटल एक्सेलरेशन है, इट्स मैग्नीट्यूड दैट इज ऑल्सो नॉट कांस्टेंट, है ना, क्योंकि v स्क्वायर बाय r, v कांस्टेंट नहीं है तो AC भी कांस्टेंट नहीं होगा. एंड टेंजेंशियल एक्सेलरेशन कुछ होगा यहाँ पर, ओके. सो दैट इज ऑल्सो नॉट कांस्टेंट AC. एंड टेंजेंशियल एक्सेलरेशन, देयर इट वाज 0 एंड हियर इट इज नॉट 0. All right. So let me give you an example. इसी diagram में, right? So let's say you have tangential acceleration. Obviously the word signifies the meaning, है ना. Tangential मतलब tangential होगा. Tangential कैसा है? यहाँ पर it can either be like this or like this. उल्टा भी हो सकता है, right? So let's say, है ना, let's say the tangential acceleration is like this, right? It is like this, यानी कि उल्टे डायरेक्शन में. Then what happens if it is in the opposite direction? Then the speed will decrease, right? Just like you are moving in a car, you apply the brakes, क्या होगा? Speed is going to decrease, right? So similarly V is going to decrease over here, है ना? And AC obviously is towards the center. ठीक है, तो ये आपको ध्यान रखना है. तो इस डायग्राम में what is happening कि जो speed है that decreases. Okay. So few salient points we have discussed. Okay. Yeah. Okay, someone is saying acceleration is change in velocity over time. Why are you taking speed constant in the expression? अच्छा देखिए, I'm saying when they have said already it is uniform circular motion, है ना? Uniform circular motion meaning speed is constant. So that is already declared. ठीक है ना? तो ये तो है ही आपके पास. So उससे we are saying tangential acceleration has to be zero. ठीक है? If tangential acceleration is there, that means speed is going to change. ठीक है ना? Speed changes, then it will become non-uniform circular motion. ठीक है? But हमारा क्वेश्चन वो नहीं था. ठीक है? और ध्यान रखिए, what's the difference? ठीक है ना? ये जो एक और चीज, अच्छा देखो, एक और चीज जो आपको जो टोटल एक्सेलरेशन है, here what is the total acceleration? Remember tangential acceleration is zero, so therefore total acceleration is centripetal acceleration only. क्योंकि यहाँ पे दो एक्सेलरेशन थे, centripetal tangential. If this is zero, total acceleration is centripetal, है ना? तो यहाँ पर I can say, if you want the fourth point, I can write down over there, है ना? Fourth point, जो total acceleration है, that is nothing but your centripetal acceleration. ठीक है? But what about over here? Here we have a total acceleration, है ना? Here we have both centripetal as well as tangential. तो total कैसे निकालेंगे? Total हम निकालेंगे using vector addition. ठीक है? Using vector addition, that is total vector क्या हो जाएगा? Centripetal acceleration का vector और tangential acceleration का vector. दोनों को vectorially लिखिए और वेक्टर एडिशन करना है. दैट्स इट, यू विल गेट द टोटल एक्सेलरेशन. ठीक है, चलिए मूविंग बैक टू द क्वेश्चन व्हाट दे वर आस्किंग. सो इस क्वेश्चन देखेंगे, इट वाज अ वेरी सिंपल क्वेश्चन यहाँ पर, है ना? बिकॉज आई हैव ऑलरेडी सेड इट इज यूनिफॉर्म सर्कुलर मोशन, है ना? एंड देन दे आर आस्किंग सेंटीपिटल एंड टेंजेंशियल, बट वी ऑलरेडी स्टडीड ना. टेंजेंशियल क्या हो जाएगा? जीरो यूनिफॉर्म सर्कुलर मोशन में, राइट? एंड व्हाट अबाउट सेंट्रीपिटल एक्सेलरेशन? वी नो द फॉर्मूला. सेंट्रीपिटल इज गिवन टू यू बाय v स्क्वायर बाय r. ठीक है, v क्या है? 2, तो ये जाएगा 2 स्क्वायर बाई 2, दैट इज 4 बाई 2, दैट इज 2 मीटर पर सेकेंड स्क्वायर. ये सेंट्रीपिटल. सो आंसर क्या हो जाएगा? 2,0, है ना? 2,0 इज गिवन टू यू ओवर हियर. सो ऑप्शन 4 इज आवर आंसर. ठीक है, चलिए लेट्स चेक एज वेल क्या कह रहे हैं. ऑप्शन 4 इज करेक्ट. चलिए moving to another question, question number 3. See this one, it's very simple. Okay, another person asking, sir, tangential acceleration to change in velocity over time, right? So it can't be zero because it's having direction. Change in velocity over time, that is dv by dt, है ना? That is d by dt of v vector. तो वो आपका टोटल एक्सेलरेशन हो जाएगा. ठीक है, टेंजेंशियल एक्सेलरेशन की जो मैग्नीट्यूड है दैट इज dv by dt. वहाँ पे v क्या है? स्पीड है. इन यूनिफॉर्म सर्कुलर मोशन स्पीड कांस्टेंट है, इसलिए टेंजेंशियल एक्सेलरेशन जीरो हो गया. ठीक है, सो इन यूनिफॉर्म सर्कुलर मोशन टेंजेंशियल एक्सेलरेशन इज नॉट देयर एट ऑल. ओके, ऑलराइट, रीड दिस क्वेश्चन, क्वेश्चन नंबर 3. इट सेज two forces F1 and F2. F1 vector is 2i cap plus 7j cap. F2 vector is 2i cap minus 4j cap Newton are acting on a body. Then magnitude of net force on the body will be. ठीक है, net force on the body. अच्छा ये कैसे निकालेंगे? Just like I said it in the previous question, है ना? When you have two vectors, just as in centripetal and tangential, उनका vector addition we did. Similarly here also you have two vectors F1 and F2, its vector addition we have to do, but that vector itself is written over here. So simple addition, that's all. So net force हम कैसे निकालेंगे? very simple addition, right? Do the addition f1 vector plus f2 vector, right? Just add करना है आपको, ठीक है? अच्छा ये देखिए add कैसे करेंगे? Both vectors are given, same unit obviously, right? Newton 2 I cap plus 7 j cap plus 2 I cap minus 4 j cap. ठीक है? How do we add it? Add the similar components, यानी कि I cap with I cap. So 2 I cap plus 2 I cap, it becomes 4 I cap. J cap with J cap, 7 minus 4 will become 3. That is plus 3 J cap. And answer's unit is in Newton. Okay? अच्छा. अब क्वेश्चन में क्या मांग रहे हैं? See over here. Find the magnitude of net force. ठीक है? तो इसका magnitude हम कैसे निकालेंगे? Magnitude is very simple, right? Remember, these are the rectangular components of that vector, है ना? I cap, J cap, K cap, if it were there. That is A, B, C. तो कैसे लिखेंगे? Magnitude under the root A square plus B square plus C square. Here obviously you only have A and B. तो ये क्या हो जाएगा? Under root A square plus B square. ठीक है? तो ये क्या हो जाएगा? 16 plus 9, that is 25. Root 25 will become 5. Right? Root 25 will become 5 Newton. ठीक है? Okay. Very easy question. This one was. अच्छा. अब few more things we can ask over here, right? F1 vector, F2 vector. Let's say if they had asked find the direction of this vector, तब कैसे करोगे आप? है ना? तब कैसे करेंगे? देखिए. I'm saying, let's say this is your F1 vector, and this is your F2 vector, right? Or rather, F2 vector is not perpendicular, है ना? 2 I cap 7 j cap and 2 I cap minus 4 j cap, है ना? So let's say if were to let's say represent it in terms of I cap and j cap, है ना? So if you want, you can represent F1 vector like this also. You can represent it in inclined form also. ठीक है? So let's represent it in inclined form. So let's say this is your I cap and j cap. ठीक है? So F1 was 2 I cap plus 7 j cap. So F1 vector will come something like this. ठीक है? So let's say F1 vector is like this. Okay. F2 vector is 2 I cap minus 4 j cap. So F2 vector will come something like this. ठीक है? So F2 vector is coming something like this. So how is the direction of resultant vector? यानी कि if you see the resultant vector हमने क्या निकाला था, है ना? देखिए resultant vector we had calculated 4 I cap plus 3 j cap, यानी कि it is coming in the first quadrant, है ना? Somewhere over here, that is it is coming like this, है ना? So resultant अगर दो vectors का if you want to draw it, how will we draw? देखिए it would be nothing but something like this. ठीक है? Resultant vector. All right. How do we get or let's say arrive at this? By using the parallelogram law of vector addition. ठीक है? Parallelogram law कैसे करते हैं? You take this and place it over here. You complete the parallelogram. तो ये जो है, this becomes the diagonal of that parallelogram. ठीक है? Just I wanted to discuss how to draw the vector diagram. That's all. ठीक है? अब इससे हम डायरेक्शन वगैरह निकाल सकते हैं. As in ये एंगल निकाल सकते हैं, वो एंगल निकाल सकते हैं. Right? Although here it will become complicated. But how to draw the diagram? I hope it is clear to you. Alright, and remember these two vectors they are not perpendicular, है ना? Although it appears as if they are perpendicular, they are not. ठीक है? और how do we check whether they are perpendicular or not? Simply take their dot product. ठीक है? अगर देखिए इन दोनों का अगर आप dot product लेंगे, what it comes? You see how do we take the dot product? I cap with I cap, है ना? That is 2 into 2, it becomes 4. Then 7 and minus 4. 7 into minus 4, it becomes minus 28. So 4 minus 28. So it's not 0. अगर 0 होता we can say they are both perpendicular. जबकि यहाँ पे दे आर नॉट परपेंडिकुलर, ठीक है. सो फ्यू थिंग्स वी डिस्कस्ड रिगार्डिंग वेक्टर्स. हालांकि यहाँ पे इट वॉज वेरी सिंपल क्वेश्चन दे हैड आस्क्ड. चलिए मूविंग टू क्वेश्चन नंबर 4 नाउ. ठीक है, एंड या द आंसर वॉज 5 न्यूटन. या सो क्वेश्चन 4 देखिए क्या कहता है ये सेइंग अ स्प्रिंग है ना, अ स्प्रिंग ऑफ फोर्स कांस्टेंट 500 न्यूटन पर मीटर हैज एन एक्सटेंशन ऑफ 4 सेंटीमीटर. ठीक है, तो इनिशियली इटसेल्फ दे हैव डिक्लेयर्ड कि एक्सटेंशन इतना है ऑलरेडी. द वर्क डन इन एक्सटेंडिंग इट फ्रॉम 4 सेंटीमीटर टू 12 सेंटीमीटर इज. अच्छा अब देखिए right, so let's say until here the spring was at natural length, so we extended it to 4 centimeter. थोड़ा सा extend किया हमने until here we brought it. ठीक है, then what happens, there will be some potential energy stored in the spring है ना, that potential energy is called elastic potential energy, right? Okay, someone is asking, sir, when to use dot product and cross product in question like question 3. It's pretty simple, है ना. Dot product meaning if you want to find the angle between the two vectors. So just as I said, if dot product comes 0, that means both vectors are perpendicular, है ना. That is why perpendicular, क्योंकि cos 90 degree is 0. So if dot product is 0, that means cos theta is 0, theta has to be 90 degree. ठीक है ना. अच्छा, क्रॉस प्रोडक्ट कब करेंगे, जब आपको ये निकालना हो कोई उन दोनों वेक्टर्स का परपेंडिकुलर. इफ यू हैव टू फाइंड अ वेक्टर दैट इज परपेंडिकुलर टू बोथ f1 एंड f2, यू हैव टू टेक क्रॉस प्रोडक्ट ऑफ f1 एंड f2. ठीक है, सो f1 वेक्टर क्रॉस f2 वेक्टर, आपको एक नया वेक्टर मिलेगा दैट विल बी परपेंडिकुलर टू बोथ f1 एंड f2. ओके, सो कमिंग ओवर हियर, four centimeter we have extended. That means some elastic potential energy will be stored in the spring. अच्छा, अब they are saying कि 4 centimeter से we are extending it even further. Okay, so this is let's say your x initial. X initial meaning the initial extension in the spring. So we have extended it further, है ना, और उसको extend किया हमने यहाँ तक, right? And now we are having the total extension over here, that is 12 centimeter. ठीक है, so I am showing it like this. तो ये क्या है आपका final extension, that is 12 centimeter. So how are we extending it? ध्यान रखिए, as it is extending, the spring force is towards left. Why? Because the spring wants to return to its original mean position. But if you are extending it, that means we are, let's say, applying an external force, है ना. So let's say we had applied that external force something like this. Okay, let me draw it like this. Let's say this is your F external. Using this F external, we are extending it even further and further and further. ठीक है. And now what are they asking? The work done in extending it. ठीक है. So remember, how do we find the work done in extending it? So you have to remember the elastic potential energy formula for the spring. ठीक है. So what is elastic potential energy stored in the spring, right? So it's given by U is equal to half k x square. That's all. ठीक है, half k x square. But here remember, if they're asking work done, तो ये it's as in work done by the external force, right? Work done by the external force, that is F I had shown over there. ठीक है, तो ये work done कैसे निकलेगा? That work done है ना by that external force is है ना given to you as U final minus U initial. ठीक है, this is the formula. If they had asked work done by the spring force in order to extend it from 4 centimeter to 12 centimeter, तब आप क्या करते? You would have done U initial minus U final. ठीक है, but यहाँ पर U final minus U initial. So that's it. Formula we are going to be using. U का क्या formula है? Half k x square. तो ये क्या बन जाएगा फिर? हाफ के यू कैन टेक इट एज कॉमन, यहाँ पे क्या आ जाएगा, हाफ के एक्स फाइनल स्क्वायर माइनस एक्स इनिशियल होल स्क्वायर, दैट्स इट, ठीक है। अच्छा, अगर पूछते हैं वर्क डन बाय स्प्रिंग फोर्स, ध्यान रखना इट वुड हैव बिकम एक्स इनिशियल स्क्वायर माइनस एक्स फाइनल स्क्वायर। एक्स इनिशियल कितना है आपका 4 सेंटीमीटर, तो दैट मीन्स ऑटोमेटिकली इट वुड हैव कम नेगेटिव, है ना, इट वुड हैव कम नेगेटिव, क्योंकि स्प्रिंग फोर्स इज टुवर्ड्स लेफ्ट और आप एक्सटेंड ऐसे कर रहे हो आप स्प्रिंग को, है ना, तो वर्क डन बाय स्प्रिंग फोर्स हैज टू बी नेगेटिव इन दैट केस। लेकिन यहाँ पे दिस वर्क डन इज गोना कम आउट टू बी पॉजिटिव। तो चलिए लेट्स सब्स्टिट्यूट द वैल्यूज। हाफ के इज हाउ मच 500, है ना। एक्स फाइनल तो ये है 12 सेंटीमीटर, एक्स फाइनल स्क्वायर विल बिकम 12 स्क्वायर, 12 अपॉन 100 मीटर, स्क्वायर करने पर 12 स्क्वायर अपॉन 100 स्क्वायर, है ना। तो वैसे ही माइनस दिस इज 4 स्क्वायर, यहाँ पर क्या है 100 स्क्वायर, सो 100 इंटू 100, ओके। सो हियर इफ यू सी you can cancel the terms, 12 square is 144 minus 16, it will become 128, 128 by 2 it will become 64, right. So this is becoming 5 into 64 by 100, 5 into 64 320, 320 by 100 will become 3.2, ठीक है। So option 1 is our answer, okay, pretty easy this question was, right. चलिए let's check the answer slide as well, yeah the answer is correct, ठीक है। चलिए अगले सवाल पे चलते हैं। It's also very simple question, this one is a shaft rotating at 3000 rpm is transmitting a power, है ना, पावर यानी कि P, है ना। द मैग्नीट्यूड ऑफ द ड्राइविंग टॉर्क इज, डायरेक्ट फॉर्मूला ओरिएंटेड क्वेश्चन, है ना। पावर इज गिवन टू यू एज P इज इक्वल टू टाउ इंटू ओमेगा, है ना। इफ इट वर फोर्स एंड वेलोसिटी यू वुड हैव रिटन पावर इज इक्वल टू F इंटू V, फोर्स इंटू वेलोसिटी, है ना। अच्छा, तो यहां पर पूछ के रहे हैं ड्राइविंग टॉर्क, दैट इज टॉर्क दे आर आस्किंग। तो टॉर्क क्या हो जाएगा, torque is nothing but power upon omega, right. Power is how much, 3.14 kilowatt, so you would write 3.14 into 10 की power 3 watt, ठीक है। omega is given to us 2 pi into frequency, right, 2 pi into frequency। अब frequency क्या given है, frequency यहाँ पर given है, right. So this is your frequency, frequency is 3000 rpm, right. So now all you got to do is substitute it over here, है ना। So what it becomes, अच्छा, तो 3000 revolutions per minute है ना, so that means how many revolutions per second, if you want you can convert it also or we can convert it over there, है ना। So this will become 3000 revolutions per minute, right. So therefore I can say 3000 revolutions upon 60, if you do it like this it will become revolutions per second, है ना। So therefore this will become how much, if you cancel it is 50, है ना। So therefore 50 revolutions per second, यानी कि frequency आपका 50 है, alright. So you can, if you want you can directly substitute it over there, alright. So if you substitute it over here and remember to write the value of pi, approximately it is 3.14, this is 50, okay. Now you can solve for it over here, 3.14 they get cancelled, right. 1000 by 2, this becomes 500, 50 and 500 get cancelled to leave you with 10 Newton meter is the value of torque, ठीक है। Option 2 is your answer. Alright, pretty easy this question was. So students often face trouble over here, how to convert frequency into omega, right? So remember this formula. Okay, alright, moving to question 6 now. So yeah, 10 Newton meter is correct. So question 6 says acceleration due to gravity on the surface of earth is g, right? Acceleration due to gravity on the surface of another planet of same density but radius half that of earth is. So they are focusing on density and radius. ठीक है, डेंसिटी एंड रेडियस. अच्छा, उसको वी आर कंपेयरिंग इट विथ एक्सेलरेशन ड्यू टू ग्रेविटी. तो उसका क्या कनेक्शन है? देखिए, दैट फॉर्मूला यू हैव टू डायरेक्टली रिमेंबर, और इफ यू वांट वी कैन डिराइव इट क्विकली, है ना. एक्सेलरेशन ड्यू टू ग्रेविटी, रिमेंबर ऑन द सरफेस वी आर टॉकिंग. सो सरफेस ऑफ अर्थ पे व्हाट्स द फॉर्मूला ऑफ जी? gm by r square, right? Now what is mass? Mass क्या है आपका? Density into volume, है ना. So I can write over here mass to be m to be density rho into volume is 4 by 3 pi r cube, है ना, because it's like a solid sphere, right, divided by r square. So if you see, right, this r square and r cube will get cancelled to leave you here with r. तो ये देखिए क्या हो गया आपका 4 pi rho g r upon 3. Okay. Now if you come over here, so small g, how is it varying with density and radius? So remember 4 pi g, they are all constants, aren't they? This is constant, this is constant, this is constant, this is constant. So rho and r. So small g varies like this, is proportional to rho and r like this, right? अब देखेंगे यहाँ पे density तो it's constant, so you can remove density over here, है ना? So we can say g is proportional to r, right? G is proportional to r. So when radius becomes half, radius of that planet is half, so acceleration due to gravity on that surface of that planet will also be half. Okay. So I can write G planet is also going to be half. Half of who? Half of G of Earth on its surface. Okay. So why is it so? I have said radius is half, therefore G is also half. So therefore answer is going to be G by 2. That's it. Okay. Let's check. Yeah. So G by 2 is correct. चलिए अगले पे चलते हैं 7वें सवाल पर. ये भी देखिए, ये भी बहुत छोटा सा सवाल है, right? Having to do with your mechanical properties of solids chapter, right? So wire of length 4 meter, length यानी कि L, stretched through 2 millimeter, that is, this is your delta L. Okay, delta L meaning change in dimension. If Young's modulus of wire is this much, the energy density of wire is. Okay. So what is energy density formula? So this formula you need to remember. Okay. It's given to you by half stress into strain, right? You can write like this. We're talking about energy density. अच्छा, अगर आप पूछते हैं total energy कितना है, so remember energy density is total energy per unit volume. So energy क्या हो जाएगा? This you have to multiply it with the total volume of the wire, है ना? Volume of the wire कैसे निकालेंगे? You need the area of cross section and the total length. ठीक है? So area of cross section is not given to you. अगर वो दिया होता तो हम निकाल लेते. Okay. Now what about stress and strain? What is the connection between the two? That is given to you by Hooke's law, right? Hooke's law क्या कहता है कि Young's modulus is equal to stress upon strain. ठीक है, so this is Young's modulus, which is given to you over here. ठीक है, this is your Young's modulus. अच्छा, अब यहाँ पर energy density we have to find out. So let's use that formula. तो क्या हो जाएगा ये? Half into stress into strain. But we don't know the stress. Stress क्या है? Remember, on that wire, or as in the cross section of that wire, a normal force is being applied. So that contributes to the stress. है ना? So stress force is not given, area of cross section is not given over here. है ना? So how do we find the stress then? Stress is very simple to find, that is Young's modulus multiplied by the strain. तो इस formula को उठाकर you have to plug it in over here, right? So what will it become? Half into Young's modulus into strain. So it will become half into Young's modulus, right? Strain whole square, right? So that's it, strain whole square. अच्छा, अब ये क्या हो जाएगा यहाँ पर? Let's substitute the values. Half into 10 raised to the power 11, right? Strain is how much? Delta L by L, है ना? Change in dimension by original dimension. So delta L is how much? 2 millimeter. 2 millimeter. Convert it and write it in meter. That is 2 into 10 raised to the power minus 3 meters upon original length, that is 4 meter whole square. ठीक है? अच्छा, अब देखिए यहाँ पर ये कट गया, it becomes 2. Then if you solve it over here, this will become, right, 10 raised to the power minus 6, right? And you open the bracket, so this will become 10 raised to the power 11 into 10 raised to the power minus 6 whole upon, remember 2 square will become 4 and 4 into 2 over here, right? So this will become 8, right? अब इसको solve करेंगे, ये क्या हो जाएगा? 10 की power 5, right? And then you have 8 also over here, है ना? So this I can write it like this. देखिए 10 raised to the power 5 over 8, है ना? इसको आप ऐसे लिखिए 1000 by 8 into 100. 1000 by 8 क्या होता है? This you have to remember, 125. This will become 125. So 125 into 100. ठीक है? So answer will become 12500. ठीक है? And this is energy density, that is energy per unit volume. ठीक है? So that is joule per meter cube. If you check the options, they have written it in scientific notation. ठीक है? Scientific notation यानी कि decimal after the first digit आएगा. So 1.25. अच्छा 1.25 करके लिखें तो क्या हो जाएगा? 1.25 multiplied by 10 की power 4, right? So if you see the options, this is going to be correct. Okay, yeah. Some student has commented, yeah, 1.25 into 10 raised to the power 4. So option 1 is correct. चलो देखते हैं. And yeah, option 1 is correct. ठीक है? So this is how we do, है ना? So इससे दो सवाल आ सकते हैं ऐसे क्वेश्चन से in your NEET. That is, find the energy density and find the energy of the total wire. ठीक है? So I told you, right? You have to multiply it by the volume, that is A into L. ठीक है? But you need area of cross section in that case. Okay, so moving to question number 8 now. अच्छा, ये देखिए, it's a very simple assertion reason based question, है ना? Assertion, it says Pascal's law is the working principle of hydraulic brakes. अच्छा, this is very true. Right? This is very true, right? क्योंकि Pascal's law क्या कहता है? What does Pascal's law state? That pressure in one part of the fluid, it is transmitted equally in all directions throughout the confined fluid. ठीक है? तो we are talking about a confined fluid. उसमें pressure कैसे transmit हो रहा है? So remember, it is transmitted equally in all directions. है ना? That is talked about in Pascal's law. अच्छा. Then they are talking about हाइड्रोलिक ब्रेक्स. अच्छा, पैस्कल्स लॉ का हाइड्रोलिक ब्रेक्स में कैसे यूज हो रहा है, राइट? सो रिमेंबर इन हाइड्रोलिक ब्रेक्स, राइट, सो लेट्स से इफ यू आर अप्लाइंग ए वेरी, लेट्स से स्मॉल फोर्स ऑन द पेडल, है ना, द स्मॉल फोर्स ऑन द पेडल इट विल ट्रांसलेट इनटू लेट्स से अ लार्ज फोर्स ऑन द व्हील, है ना, जो गाड़ी की जो व्हील है उस पर लार्ज फोर्स लगेगी, ओनली देन द व्हील विल कम टू अ स्टॉप, है ना. सो छोटे से फोर्स पेडल पर व्हेन यू अप्लाई अ स्मॉल फोर्स इट इज ट्रांसमिटेड एज अ लार्ज फोर्स ऑन द व्हील. वो कैसे? यूजिंग पैस्कल्स लॉ, है ना. दैट इज द प्रेशर ऑन द पेडल इज सेम एज द प्रेशर दैट इज बीइंग ट्रांसमिटेड टू द व्हील. ठीक है, दैट इज F by A और F by A, right? That's what we are doing. Okay. So if I write it like this, आप ऐसे याद रख सकते हो, हाँ. So F1 by A1 is equal to F2 by A2, right? So this pressure becomes this pressure, and they are both equal. All right. So yeah, Pascal's law is indeed the working principle of hydraulic brakes. So yes, this is correct. Very true. Second one says pressure is equal to thrust into area. ठीक है ना, तो इसमें ध्यान रखिए and you can remember also, okay, just what I told you, right? That is pressure on pedal to wheel. Okay, so pedal per small force, what I told you I am writing, right? And here you have a, because wheel is much larger, है ना, so larger force, और उसको if you want you can also call it as larger braking force. ठीक है ना, thus leading to hydraulic brakes. All right. Anyway, coming to this one, pressure is equal to thrust into area. This is correct, but this is wrong. ऐसा क्यों? Because thrust is nothing but your force only, है ना. और pressure का अभी हमने what formula we studied over here? Force upon area, right? So it should be thrust upon area, not thrust into area. Okay. So pressure is actually thrust upon area. All right. So this is wrong. Assertion is true, but reason is wrong. All right. Let's check the answer. है ना, तो ये याद रखिए, statements याद रखिए, जो का त्यो, something similar can be asked in your NEET exam. So yeah, option 3 is correct. चलिए, moving to question number 9 now. है ना, ये भी देखिए, it's also a very simple question if you remember the formula. है ना, let's read on. So it says a black body, right? A black body has wavelength lambda m corresponding to maximum intensity at itna temperature, right? So let's call this temperature as T1. Its corresponding wavelength at 2500 Kelvin will be. So remember, we are talking about the wavelength corresponding to maximum intensity, right? Maximum intensity of what? Maximum intensity of emitted radiation. है ना? So here we use which law? You have to remember the name of the law as well, my dear friends. So Wien's displacement law, है ना? तो ये क्या कहता है? That the product, right, that is lambda m multiplied by temperature, that is equal to a constant. Okay, that constant is denoted by B. ठीक है, it has a constant specific value. लेकिन ये जो product है, that will remain the same. ठीक है, because remember we are talking about the lambda m corresponding to maximum intensity, और वो maximum intensity किस temperature पे है. All right, so therefore initially it is lambda m, that is the wavelength, right? So wavelength is lambda m corresponding to temperature is 1500 Kelvin, that is your T1, right? And also remember you have to write it in SI unit, है ना? तो temperature you have to write it in Kelvin. खास करके बच्चे, they often mistake that they do, right? So here let's say in NEET they are writing 1500 degrees Celsius, है ना? So you cannot write 1500 over here. Why? Because this T you have to write it in Kelvin, not degree Celsius, है ना? Kelvin is the SI unit. Okay, अच्छा, this would be equal to the corresponding wavelength जो हमको नहीं पता है ना. So let's call it lambda m dash at a different temperature. वो कितना 2500. So here the temperature is 2500 Kelvin. Kelvin is written in the question, so we can use the same value Kelvin, that is 2500 Kelvin. Okay, so that's it, very simple. We have to solve for it, right? So if you solve, देखिए क्या हो जाएगा, 0 0 कैंसल है ना, ये कट गए, 5 से this becomes 3 and this becomes 5 over here, right? Thereby leaving you with, you have to find this wavelength, right? Remember, you have to find this wavelength. That is lambda m dash you have to find, right? So lambda m dash क्या हो जाएगा? Bring this 5 to the denominator, right? This will become 3 lambda m over 5. Okay, 3 lambda m over 5. It's pretty simple and it's given to you in the options also over here. So option 1 is our answer. Okay, yeah. So let's check. Yeah, option 1 is correct. ठीक है. So first option is correct. Moving to question number 10 now. बहुत छोटा सा सवाल था, right? Okay. Now what about this one? It's a very straightforward question, है ना? Nothing complicated over here. If you read on, which of the following is not a thermodynamic variable? Not a thermodynamic variable, and if you see the question में आंसर भी छिपा हुआ है, right? Because they are saying thermodynamic variable. लेकिन but if you read the options, what's the first option? Gas constant. So constant यानी कि obviously है ना, ये चीज़ जो है it remains constant है ना. Gas constant क्या होता है वो? That R, isn't it? Which we have studied. R के 2 units होते हैं in joule में और pressure जब ATM होता है, right? So this remains the same. इसकी value change नहीं होगी. So it's not a variable. Constant लिखा है ना. So therefore this is the answer. It's not a variable. जबकि ये जो 3 चीज़ें हैं, they can vary depending on different parameters, right? Pressure, volume, temperature of a gas. तो ये तीनों तो गलत हो गए, right? Because they are saying not a thermodynamic variable. So they are thermodynamic variables, है ना? तो इसलिए ये तीनों गलत है, वो सही. Okay. Pretty straightforward, na? This question was. Moving to question number 10 now. Question 10 we have already done. Question number 11 now. अच्छा, ये देखिए, ये क्वेश्चन देखिए. It's also direct question. Which among the following modes of heat transfer does not require a medium? Does not require a medium. ठीक है, it does not or it requires. Students can make mistakes, so उस पर ध्यान रखना है. हाँ, conduction, convection and radiation. अच्छा देखिए, conduction, convection and radiation, right? If you open your NCERT, there is a very beautiful diagram that has been drawn, है ना? That is, आप देखेंगे आग जल रहा है, right? आग जल रहा है and एक 3 लोग खड़े हैं वहाँ पर, right? एक बंदा जो है फायर के ऊपर हाथ को रखा हुआ है, right? Little above, फायर को टच नहीं किया, little above, little away, ऊपर रखा है, ठीक है? So उसको, how is he able to feel the heat? Using which mode of heat transfer? It would be this one. Just ऊपर रखा है उसने, right? So that is, उसके लिए how is heat is traveling? तो for convection we say heat transfer occurs through fluids, ठीक है? Heat transfer will occur through fluids. तो जैसे कि air जो है it's a fluid, so heat has been transferred through it. अच्छा, दूसरा एक बंदा है, थोड़ा सा he is sitting little further away, right? Little further away. He is also able to feel the heat. For him, how is the heat traveling? उसके लिए हम बोलेंगे radiation. आई विल कम टू रेडिएशन इन अ बिट अगेन। और एक और तीसरा भी बंदा है, इफ यू सी दैट डायग्राम देयर इज अ रॉड, ठीक है ना, उसने एक रॉड पकड़ा हुआ है एंड द रॉड हैज बीन इंसर्टेड इनटू द फायर एंड ही इज आल्सो एबल टू फील द हीट। सो हाउ इज ही फीलिंग द हीट? थ्रू कंडक्शन, ठीक है। सो कंडक्शन एज ए हीट इज ट्रैवलिंग थ्रू सॉलिड्स, ध्यान रखना। सो हीट ट्रांसफर थ्रू सॉलिड उसको कंडक्शन कहते हैं, थ्रू फ्लूइड्स यानी कि लिक्विड और गैस उसको हम कन्वेक्शन कहते हैं। व्हाट अबाउट रेडिएशन? उसके लिए हीट ट्रांसफर डज नॉट रिक्वायर एनी मीडियम, ठीक है। सो इसके लिए नो मीडियम इज रिक्वायर्ड। No medium is required, and if you remember, just a few questions back we talked about a black body, है ना, heat emitted by a black body, heat absorbed by a black body, right? We also study in the chapter Stefan-Boltzmann law, right? That is sigma a t to the power 4, है ना, for a black body, क्योंकि वहाँ पर जो emissivity है that is 1. So sigma a t to the power 4, that covers which topic? इन तीनों में से that is covering the radiation topic, ध्यान रखना, right? So if you come back to the question, they're asking which mode of heat transfer does not require a medium? So yeah, it is radiation, ठीक है। कंडक्शन के लिए you require a solid, इसके लिए तो चाहिए you require a medium, है ना, that is fluids, और इसके लिए ज़रूरत नहीं है। और if you want I can give you another example, है ना, that is सूरज और धरती, right? So from the sun that heat is traveling, is it traveling through a medium? No, it's traveling through vacuum, है ना। So that is which mode of heat transfer? Radiation only. All right, so pretty simple question this one was, right? So let's check, है ना, yeah, so radiation is correct. चलिए अगले में चले 12वें क्वेश्चन पर, right? A 12वां क्वेश्चन, another interesting question for you guys, right? Let's read this one. It says a 1 meter long string, इसका मास गिवन है आपको 40 grams, तो यानी कि क्या क्या गिवन है? Length is given over here, okay, or if you want I can write it over here. Length is given 1 meter and mass is given to you 40 grams. So let's read on. It's saying it's tied tightly at its two ends. So दो ends पे it has been tied tightly. If tension in the string is 100 Newton, so tension is also given. The fundamental frequency of string is, ठीक है, tied tightly at its two ends, है ना। तो देखिए एक डायग्राम हम बनाते हैं, सिंपल सा डायग्राम। So let me draw that diagram like this, okay. ठीक है, what are they signifying? That the ends of the string have been held at their place over here, ठीक है, that's all. तो यानी कि for that string इन दो positions पर what has been formed? Node is formed. So always remember, है ना। So node पे, so at the nodes you guys can remember, right, that the displacement is equal to 0, ठीक है। Displacement is equal to 0. So obviously at these ends it has been held, so there will be no displacement at these ends, है ना। ऐसा तो नहीं है कि इस end पर string जो है ऐसे it can oscillate like this, that's not happening, right? So we say this is also node and this is also node. Now if we go back to the question, then you focus over here, they're talking about the fundamental frequency. अच्छा, what about frequency? How do we write frequency? Frequency is given by the simple formula, right? That is speed upon wavelength, because speed is given by f into lambda. Speed upon wavelength. So this formula you have to remember always, right? So fundamental frequency, है ना, तो उसके लिए remember if this is the original setup, you have to leave it like this only, है ना, यानी कि there will be no additional nodes in this diagram, ठीक है ना। So let's say if I put another node over here, यानी कि यहाँ पर एक और पॉइंट है जहाँ पर डिस्प्लेसमेंट इज 0, then this won't cause the fundamental frequency, ठीक है। Let me explain. देखिए ये लेंथ कितना है L, ठीक है, एंड मिनिमम डिस्टेंस बिटवीन टू नोड्स, ये क्या हो जाएगा, दिस इज लैम्डा बाई टू, दिस इज गिवन टू एस लैम्डा बाई टू, ठीक है ना। तो जब आप इसको लोगे एज दी डायग्राम, तो ये डिस्टेंस क्या हो जाएगा, लैम्डा बाई टू इन दोनों के बीच में, सो लैम्डा बाई टू इज इक्वल टू एल। सो इससे जो लैम्डा मिलेगा, द लैम्डा यू आर गोना गेट फ्रॉम हियर, दैट लैम्डा इज गोना बी मैक्सिमम. So when you put it over here, that lambda maximum will contribute to the minimum frequency. That is why I am saying, okay. But let's say what happens if I introduce a node over here. If I introduce a node over here, then what will happen? This length will be lambda by 2. That is also lambda by 2. Lambda by 2 plus lambda by 2 will become lambda. Lambda is equal to L. So अब यहाँ पर length, that is wavelength, has decreased, isn't it? Because here if you see, I am saying lambda by 2 is equal to L. That is lambda is equal to 2L. But if I introduce additional load, then wavelength will become L. That is wavelength has decreased. So it's no longer maximum wavelength. So if it is not maximum wavelength, it won't cause minimum frequency. Okay, so this you have to remember. Huh? So for the fundamental mode, this is the lambda for this diagram. Substitute it over there. Okay? And what about velocity? Velocity is also given by a simple formula. देखिए. So frequency will become v by lambda. So velocity is given to you as like this, under root tension by mu. ठीक है? Tension by mu. Mu is your mass per unit length. All right. And then you obviously you have your lambda. Lambda is 2 into L. That's it. If you solve for this, you will get the answer. अच्छा. So let's solve. इसमें देखिए, substitute the values. Tension is given to you as 100, है ना? 100. मास पर यूनिट लेंथ क्या हो जाएगा, मास इज 40 ग्राम, केजी में लिखिए, दिस विल बी 40 बाई 1000, है ना, 40 बाई 1000, दैट इज 4 बाई 100 kg, आई कैन राइट लाइक दिस, है ना। तो मास पर यूनिट लेंथ क्या हो जाएगा, मास क्या हो जाएगा 4 बाई 100 kg अपॉन लेंथ, अपॉन लेंथ वो न्यूमरेटर में चला जाएगा, एंड लेंथ इज हाउ मच, it's given to you 1 meter only. Okay, then in the denominator you have 2 times of length, length is again 1 meter only. So just solve for it. ये देखिए क्या हो जाएगा, 100 into 100, that is 100 square by 4. So उसका रूट लेंगे, क्या हो जाएगा, 100 square by 4 का रूट 100 upon under root of 4, under root of 4 is 2, है ना। अंडर रूट 4 इज 2 और यहाँ पर एक और 2 है, राइट। सो दिस विल बिकम 100 by 4, राइट, 100 by 4. व्हाट विल दिस बिकम, 25 हर्ट्ज इज योर आंसर. ऑलराइट, सो 25 हर्ट्ज, pretty simple question this one was, right? Very easily we got it. Okay, so please remember the steps, ठीक है ना. And let's say if they had asked find the next frequency, right, the next frequency, if they're asked apart after the fundamental frequency, है ना, तो वो कैसे निकालेंगे, just what I told you, how to find the wavelength, उसके using, ठीक है. So next frequency meaning you will introduce one node, तो ये क्या हो जाएगा, lambda by 2 plus lambda by 2 equal to L. So वैसे ही है आपका एक frequency के एक you will get a series of harmonics. Okay, but anyway for fundamental frequency you have to do it like this. All right, I hope this is clear. अगले क्वेश्चन पे चलते हैं. क्वेश्चन नंबर, या दिस इज करेक्ट, क्वेश्चन नंबर 13. अच्छा देखिए क्वेश्चन 13 देखिए, इट्स वेरी इंटरेस्टिंग क्वेश्चन. 2 इलेक्ट्रिक डाइपोल्स ऑफ डाइपोल मोमेंट, वो भी गिवन है, 2 कूलम मीटर एंड 4 कूलम मीटर. ये तो सही है, डाइपोल मोमेंट का फॉर्मूला है ना. डाइपोल मोमेंट का क्या फॉर्मूला होता है, रिमेंबर डाइपोल इट कंसिस्ट ऑफ 2 चार्जेस, है ना, माइनस क्यू एंड प्लस क्यू, separated by a distance, right? This is one charge, this is the other charge. So dipole moment क्या हो जाएगा, it is given to you by Q into D. Okay, the charge multiplied by the distance between the charges. Alright, anyway, reading the question further, it says both dipoles of so and so dipole moment are kept inside a cube of side A meter they have given. Okay, total electric flux linked with the cube is. So total electric flux. How do we find the total electric flux? देखिए, total electric flux is given to you by the Gauss law, that is charge enclosed within that volume, right, that we are considering, divided by epsilon naught. Okay. Now about that volume, what are we asking? The total electric flux through that volume. Okay, through that volume. All right. So let's say, for example, we have a surface like this, right? A closed surface enclosing some volume, and some charges are also there in that volume. Okay. And you have electric field lines coming out, contributing to electric flux. Okay, na? So let's say, for example, the charges enclosed are Q1, Q2, and here you have Q3. Okay. So for this diagram, total electric flux, क्या लिखेंगे हम? Simply Q1 plus Q2, Q3 नहीं लिखेंगे. So please understand that, right? So here the answer will become simply Q1 plus Q2 upon epsilon naught. That's it. Okay, that's it. Achha. Now coming back to the question, they are saying दो dipoles हैं or they have some dipole moment, something, right? So let's say for the first dipole moment, the charges are Q1 and minus Q1. Similarly for the second क्या हो जाएगा? Q2 and minus Q2, and they are both kept inside a cube. अच्छा, देखिए. So let's say this is that cube, है ना? And inside the cube we are placing both charges. So how am I placing? Huh? So let's say I am having Q1 charge over here and minus Q1 charge over here. This is one dipole, right? Second dipole, let's say I have placed it over here, but it is still inside the cube only. Okay, that is minus Q2 and plus Q2, right? I hope you don't get confused by the diagram. All charges are inside the cube. Okay. So remember, so what will be Q enclosed then? Total Q enclosed? It will be nothing but add them up, simple addition, right? That is Q1 plus minus Q1, right? Q1 plus minus Q1, then you have minus Q2 plus Q2. So this comes out to be 0, right? Because they cancel out, right? If total charge enclosed is 0, therefore the flux through that cube, will also become 0, isn't it? Charge enclosed by epsilon naught. So it's a pretty straightforward, easy question. Okay. So the answer here is going to be 0. Okay, it's going to be 0. Okay. Let me ask a different question for you guys. एक छोटा सा एक अलग सा एक सवाल, right? So let's say once again you have a cube, once again you have a dipole, but two dipoles, है ना? Let me give you the charges also, right? So let's say one charge is minus 3 coulomb placed over here, and that positive charge, corresponding positive charge plus 3 coulomb, it has been placed over here at some distance from this minus 3 coulomb. But notice one charge is inside, another charge is outside. Okay. Similarly, you have another dipole, and another dipole, that is, let's say 4 coulomb and minus 4 coulomb. That minus 4 coulomb is placed somewhere over there. Okay, or if you want, I can place it over here. Anywhere you can place it, doesn't matter. it is outside. Then if I were to ask you find the total flux through this cube, then also will it be 0? Then also will it be 0? It won't be 0 for this, because both dipoles are not inside the cube, right? One charge is inside, another charge is outside. So therefore the total charge enclosed within the cube, right? How do we find flux through the cube? Use that formula, charge enclosed by epsilon naught. Okay, so charge enclosed is how much? Minus 3 plus 4, minus 3 coulomb plus 4 coulomb upon epsilon naught, right? So this will become 1 coulomb, right? So 1 coulomb by epsilon naught. Use the appropriate SI units, you will get the answer also, right? So here it is not 0. So if you come back to the options, right? So the answer, if you see, the options have been written like this, right? 6 by epsilon naught, 2 by epsilon naught for such a question, what we did just now. But not over here. For this question, it is 0 only. Okay, so don't get confused. All right. So moving to the next one. Question number 14. Okay. Yeah, so this one is 0. Question 14 says, if you read, it's a very simple question, right? The electric force experienced by a point charge of 1 mu coulomb. Let's call this charge as Q test charge. Okay, so the force experienced by this test charge is given to you over here. This is the force experienced. The magnitude of electric field at that point due to the source charges. Okay, due to the source charges. So here also students might get confused. That is, sir, ये जो electric field पूछ रहे हैं, is it because of this charge or source charge? So ये आपको confusion हो सकता है, right? So remember, electric field is due to source charge only, and that electric field we are measuring at, let's say, point P. Okay? So this is, let's say, the source. Okay? And here at point P, we are supposed to find the electric field. Okay? Electric field is, let's say, like this. This is your electric field. Or इसी point P पर you have placed the test charge. Okay? So this is your test charge. Okay. So we are saying the force experienced by this point charge, that is this test charge we are talking. So इसके ऊपर force क्या होगा? The force on this test charge is very basic and it's given to you by F is equal to Q into E. Right? F is equal to Q into E, that is which Q? This Q test charge. Okay? Multiplied by the electric field. Alright. And all that, that's it. That's it. We got this question. Hai na? So just substitute the values, you will get the answer. So if we solve this over here, test charge is given 1 mu coulomb, that is 10 raised to the power minus 6 coulombs into electric field is how much? Electric field we have to find out, right? Okay, so electric field is E only. Okay, force is given to you over here, that is 5 into 10 raised to the power minus 3. Okay, so from this electric field is coming 5 into 10 raised to the power minus 3 over 10 raised to the power minus 6. Okay, now you can take this to the numerator. This becomes 5 into 10 raised to the power 6 into 10 raised to the power minus 3. तो क्या हो जाएगा? 5 into 10 की power 3. Right? 5 into 10 की power 6 minus 3. 5 into 10 की power 3 as the electric field magnitude, and you can write the unit also. Right? So unit is Newton per coulomb. Okay? And which is given to you over here. Okay? That's it. Let's check the answer slide. And yeah, obviously this, if I were to, let's say, discuss about the direction, charges keep depending. So let's say here, if you look at the diagram I had drawn, Q source ऐसा था, and we had drawn electric field like this, away from that charge. So therefore Q source, I am taking it to be a positive point charge. Okay? Something like this. क्योंकि for a positive charge, the electric field lines are going further away from that charge. जबकि for a negative charge, as you can see, they are penetrating into the charge. अच्छा, अब इस diagram और इस diagram में क्या अंतर है? between this one and this one. Here if you see, the number of electric field lines are much more, and if you see they are also closely spaced, है ना. तो यानी कि the magnitude of this negative point charge is much higher than this charge. आप समझ रहे? So if I were to write down, ठीक है ना, so here let's say this is let's call it, this is Q1, है ना, and this is Q2, ठीक है. So I can say that the magnitude of Q2 is more than magnitude of Q1, ठीक है. For example, this is let's say -2 कूलम, तो ये कितना है, माइनस उतना ज़्यादा, ठीक है. नंबर ऑफ फील्ड लाइन्स आप गिनिए, इसके कितना ज़्यादा है, how many times this is more. Similarly this Q2 will be that many times more than Q1, ठीक है. So for example, अगर ये यहाँ पर कितने हैं, 3, 2, 5, 8 लाइन्स है ना, यहाँ पे 8 है और वहाँ पे मान लीजिए 40 है, तो यानी कि 5 times more, that is magnitude of Q2 will also be 5 times more. But here obviously you can count and you can find out, ठीक है. So yeah, so answer to this question was option 1 only. Okay, coming to question 15 now. अच्छा ये देखिए P क्या कह रहा है. If charge on capacitor is increased by 2 coulomb, ठीक है, then energy stored in it increases by 44%. The original charge on the capacitor is. अच्छा, charge और energy stored में what is the connection? तो ध्यान रखिए, energy stored in capacitor, है ना, तो U that is given to you by half CV square, or you can also write it like this, half into Q square by C, ठीक है, because Q is equal to CV, ठीक है. और ध्यान रखिए, कैपेसिटर जो है उसके डायमेंशंस वी आर नॉट चेंजिंग, दैट इज सेपरेशन बिटवीन द प्लेट्स एंड एरिया ऑफ क्रॉस सेक्शन, दैट इज नॉट चेंजिंग, है ना. नथिंग इज गिवन ओवर हियर, वी आर ओनली चेंजिंग द चार्ज ऑन द कैपेसिटर, दैट इज Q वी आर चेंजिंग, correspondingly U is also changing, ठीक है. अच्छा, if you see what are they saying, charge is increased by 2 coulomb, that means this RHS will become what now, it becomes Q plus 2 whole square by 2C, ये हो गया. Correspondingly you will get a new energy stored, and that they are saying this energy stored increases by 44%. तो यानी कि this becomes U plus 44% of U, that is U plus this is 44 by 100, that is 0.44, तो ये पूरा क्या हो जाएगा फिर 1 plus 0.44, that is 1.44 U. Okay, so if you want I can directly write it over here. Okay, 1.44 U. अच्छा, अब क्या करेंगे, what do we do, we can take ratio over here, ठीक है, this one divided by this one, तो ये RHS divided by वो RHS, ये LHS divided by वो LHS. So see what it becomes, this one divided by that one, right? So this simply becomes 1.44 over here, right? Or if you want I can write it also and then we can cancel it out, no worries. And similarly this one divided by this one, so 2C and 2C will get cancelled. So what is left with is Q plus 2 whole square over Q square. Okay, now U and U will get cancelled and here it becomes 1.44. Now what you do, you take square root both sides. अच्छा, square root of 1.44 क्या होता है, 1.2, है कि नहीं, because 12 into 12 is 144, है ना, और फिर 1.2 into 1.2 क्या हो जाएगा, 1.44. So this will become, after taking square root both sides, this will become 1.2 is equal to, here also take square root of whole, this will simply become Q plus 2 upon Q. Okay, and remember we are supposed to find the original charge on the capacitor, that is Q only we are supposed to find, ठीक है. Bring this over here, it becomes 1.2 Q, bring that Q over here, so 1.2 Q minus Q becoming 0.2 Q, right? 0.2 Q is equal to, here you leave it with 2 only. Okay, This is 2 by 10, 2 and 2 will get cancelled, 10 goes over there, therefore what you are left with is Q is equal to 10 coulomb. Okay, so option 2 is our answer. Right, so please remember the original formula that has been asked. So if you know the original formula, you can solve it. चलिए अगले पे चले. Yeah, 10 coulomb is correct, है ना. Question 16. Question 16 पे चलते हैं. See what it says. A wire of resistance 10 ohm is stretched to twice its original length. The resistance of half of the stretched wire is. Right. So remember, original wire का resistance क्या है? 10 ohm. ठीक है. नया लेंथ क्या हो गया? Twice. So remember, original wire का length कितना है? L. Area is how much? A. So what is the volume of that wire? Volume is A into L. Okay. But then they are saying twice stretched to twice its original length. अच्छा, अब देखो, length हो गया twice. But remember, the volume has to remain the same. तो volume तो अभी भी A into L ही है. So what will become the area of cross section? Right? Area of cross section कैसे निकालेंगे? Remember, length into area. ये क्या हो जाएगा आपका? वॉल्यूम, है ना. तो एरिया कैसे आएगा? वॉल्यूम अपॉन लेंथ. सो वॉल्यूम क्या है? A इंटू एल अपॉन लेंथ क्या है? 2L. सो एरिया ऑफ क्रॉस सेक्शन बिकम्स A by 2. ओके. Now if you read the question once again, अच्छा अब देखिए, आप ट्राई करिए एक बार. We can take a small break. ठीक है, 2-3 मिनट का. Try this question. ये देखिए मैंने हिंट आपको दे दिया. Yeah, so some are saying 40 ohm or 20 ohm, है ना. अच्छा देखिए कैसे करेंगे. देखिए ओरिजिनल रेजिस्टेंस दे हैव सेड 10 ohm, है ना. तो यानी कि फॉर द ओरिजिनल वायर, हाउ डू यू राइट द रेजिस्टेंस? Resistance is given to you as, that is 10 ohm, that is nothing but rho L by A, right? Rho L by A. Okay. अच्छा, so this is the value of rho L by A. लेकिन, but remember, they are not asking resistance of the new stretched wire. If you read, वो क्या कह रहे हैं? Resistance of half of the stretched wire. So stretched wire का आधा. तो यानी कि स्ट्रेचड वायर का एरिया ऑफ क्रॉस सेक्शन तो A by 2 है, बट टोटल लेंथ तो 2L था. अब आधा क्या हो जाएगा? द लेंथ विल बिकम L, राइट. सो व्हाट अबाउट द रेजिस्टेंस देन? सो द न्यू रेजिस्टेंस इज गोना बी रो इंटू L डैश बाई A डैश. रिमेंबर द रेजिस्टिविटी रो विल रिमेन द सेम, है ना, क्योंकि मटेरियल को हम नहीं बदल रहे. द लेंथ विल बिकम L ओनली नाउ, है कि नहीं? half of this new wire, है ना? So half of 2L is L only, but area of cross section is A by 2. So here you write A by 2. Right? So what will this become? 2 times of rho L by A. Now rho L by A, क्या है rho L by A? This we have written, है ना? Rho L by A is 10 ohm. तो ये क्या हो जाएगा फिर? 2 into 10. It is 20 ohm is your answer. ठीक है, 20 ohm is your answer. अच्छा, अगर वो पूछते find the resistance of the stretched wire, तब आप क्या करते हैं? ये length you would be using. So rho into 2L by A by 2, that will become 4 times of rho L by A. So 4 times of 10, that is 40 ohm. अभी लेकिन 20 ohm is the answer. ठीक है? Let's check. जी हाँ, ठीक है, 20 ohm is the answer. चलिए तो अगले चलते हैं 17वें क्वेश्चन पर, क्वेश्चन नंबर 17, है ना? सो लेट्स सी व्हाट इट सेज. करंट सेंसिटिविटी ऑफ अ मूविंग कॉइल गैल्वेनोमीटर कैन बी इंक्रीज्ड बाय डिक्रीजिंग. ठीक है, सो फर्स्ट व्हाट इज करंट सेंसिटिविटी ऑफ अ मूविंग कॉइल गैल्वेनोमीटर? तो ये तो है आपका गैल्वेनोमीटर, है ना? करंट सेंसिटिविटी, हाउ डू वी डिफाइन इट? तो ध्यान रखिए, this remember you have the pretty much the same diagram in your NCERT also, right? Radial magnetic field, है ना? Soft iron core is there. We denote it as current sensitivity, IS, also we denote it as IS, S for sensitivity, है ना? तो ये क्या है actually? Deflection per unit current. ठीक है? Deflection per unit current. तो इसको एक्चुअली IS भी कहते हैं. ऑलराइट, सो एंड दिस गोज बाय द फॉर्मूला NAB by K. ठीक है, NAB by K, और इसी को हम जो है IS भी कहते हैं. इफ यू वांट आई विल राइट इट ओवर हियर. दिस इज प्रीटी मच IS ओनली. ओके, सो प्लीज रिमेंबर. ओके, NAB by K. अब क्वेश्चन पे जाएंगे. N इज नंबर ऑफ टर्न्स, A इज लूप एरिया, B इज मैग्नेटिक फील्ड, K is torsional constant, है ना? So if you want to increase current sensitivity, you can increase N or increase A or increase B. But here they are saying by decreasing. So by decreasing what? See, if you decrease N, current sensitivity will also decrease. It's not going to increase, है ना? क्योंकि ये तो proportional है current sensitivity के. So decrease किसे करना होगा? You have to decrease this denominator. That is K. That's it. So if you remember the formula, you know the answer. ठीक है, so the answer is option 4, the torsional constant of the spring that we are talking about over here. ठीक है, let's go to the next question, right? And yeah, so this is correct. Question 18, right? So question 18, it's also a very direct question. This one is also, right? So let's read on. It says, which magnetic material has susceptibility less than 0, है ना? Susceptibility less than 0. तो इसके लिए for this question you need to visualize and remember the diagram. ये जो 3 magnetic materials के लिए जो diagram है, right? 2 diagrams are already drawn in your copy also. As in copy, as in I'm talking about the NCERT, huh? So magnetic, then you have paramagnetic, ferromagnetic material. Okay, paramagnetic material, है ना? So इसके लिए remember the diagram is drawn in your NCERT. If you open that magnetism and matter chapter, है ना, एक table is drawn. And below the table you have 2 diagrams of 2 materials, है ना? तो उसके through we are trying to pass an external magnetic field. When we try to pass external magnetic field through diamagnetic material, what happens? That magnetic field is repelled by this diamagnetic material. तो यानी कि वो external magnetic field अंदर घुसेगा ही नहीं ठीक से, है ना? It's getting repelled and going like this. If you remember, है ना? ऐसे it goes like this. Through that material it is not passing. It is going like this. But for paramagnetic, So we say for diamagnetic, it is feebly repelled. We call it like this. Feebly repelled. Right? As in, who is repelling who? Those magnetic field, that external magnetic field lines are getting repelled by the material, the diamagnetic material. What about paramagnetic? It is getting feebly attracted. Okay? So through this one, a few external magnetic field lines will pass through that material. So ऐसे नहीं जाएगा, it goes through the material, but a few of them will go through the material. Whereas for ferromagnetic, most of them will go through the material. क्योंकि ferromagnetic है ना, so it shows strong attraction. ठीक है? So if you want, I can write over here, strong attraction. ठीक है ना? Just a minute. Yeah. Let me write over here. ठीक है? So feebly repelled, repel यानी कि almost कुछ भी नहीं जा रहा through that material, है ना? So therefore we say this xi is less than 0. Paramagnetic, कुछ field lines जा रही हैं, so we say this xi is more than 0. ठीक है? And for strong attraction, it is much higher than 0. ठीक है ना, जो xi है. All right, so it's much higher. All right, and xi is nothing but your susceptibility. Okay, so which material has susceptibility less than 0? Obviously your diamagnetic one. All right, not those two. So diamagnetic is our answer. Okay, and obviously this fourth option also, if you see, value less than 0 is not possible. Yeah, so this is also wrong. Right, and those two obviously they are wrong for both of them. Right. If you remember xi, then you can talk about mu r. Mu r is your relative permeability. Right. So that also we can talk. Mu r, remember, is 1 plus xi. Right. So 1 plus xi, if you do add 1 both sides, 1 plus xi will become mu r less than, here 1 if you add becomes 1. Similarly here also add 1 both sides, mu r is more than 1, whereas over here mu r is much higher than 1. Right. So and you can cross check with that table and you can remember it like this. Okay. So why is it so? I have already told you. Option 3. Right. So let's check. And yeah, option 3 is correct. ठीक है, चलिए अब हम आते हैं क्वेश्चन नंबर 19 पे. See what it says, an EMF of 8 volt is induced across the ends of an inductor. So EMF is induced. ठीक है, so current through it is changing. Is it increasing or decreasing? It changes from 5 ampere to 1 ampere. It's decreasing. Right, uniformly in 2 milliseconds. The value of self inductance is. Right, so remember here if you want you can directly use that magnitude formula and you can find it out. Right. So this, remember, is your current. This is the time, 2 millisecond, right, and this is your EMF, epsilon. All right. So value of self inductance. So remember you have, let's say 2 inductors like this, right, and current is, let's say, flowing through them from the left to the right. Right, and let's say what happens, current is increasing. So current is increasing like this, है ना? So then how is the potential drop occurring across this inductor? So inductor क्या कर रहा है? Using Lenz's law we can say it is going to oppose this increase in current. Oppose कैसे करेगा? तो potential drop जो है ऐसा follow होगा, देखो, here plus and here minus. Right, that is, this will behave like a battery, and this battery is nothing but your EMF induced, right, and this is trying to oppose, है ना, उल्टे direction में देखिए, it is trying to oppose, that is, it will try to create a induced current in the reverse direction. Okay, so that is why we are saying it is opposing. But here if you see, that's why it's written induced EMF opposes the increase. But here if you see, here also current is flowing from left to right, but here the current is not increasing, it is decreasing. So here also that inductor will try to oppose this decrease. How? Potential drop देखो कैसा होगा? Potential drop देखो ऐसा होगा, ठीक है, potential drop ऐसा होगा, ठीक है. तो यहाँ पर I was saying कि यहाँ पर जो है आपका current induced ऐसे उल्टे डायरेक्शन में फ्लो हो रहा है, but here this induced EMF, current induced is flowing in the same direction. Okay. Lot of students have doubt as well. I hope it is clear now. है ना? It is trying to support this current. है ना? This induced EMF is trying to support this current because this current is decreasing. It will oppose that decrease by supporting. ठीक है? So like this. Okay, anyway, but here obviously for the question no such directions etc. is required. If you remember the formula, you can easily do it. And what is the formula for this induced EMF in both cases? You can use minus L di by dt. है ना? That's it. So if you see induced EMF minus L di by dt, that minus will take care whether it is increasing or decreasing. है? अच्छा, induced EMF कितना है? They have said 8 volt. 8 या minus L we are supposed to find out. है ना? di is the change in current. That is final minus initial. Final is how much? 1 ampere minus initial 5. So 1 minus 5. Right? 1 minus 5 like this. dt is the time taken. Time taken is how much? 2 millisecond. That is a small time taken. 2 millisecond meaning 2 into 10 raised power minus 3 second. Right? You have to solve it over here. So this becomes, if you see minus 4, minus minus will become plus 4. 4 and 8 will get cancelled. है ना? Here it will become 2. So this becomes 2 into this thing. That is L. Right? So L क्या आ गया आपका? 2 into 2, that is 4. 4, and what is the unit of inductance? Henry. तो ये क्या हम लिखेंगे? 4 Henry or 4 millihenry? We will write millihenry. Okay, so yeah, so one student has commented yes, 4 millihenry is correct. So if you see the option 3 is correct. ठीक है? Yeah, so let's check. And yeah, it is correct. ठीक है? I hope the session is going on interesting, right? सबको समझ आ रहा है I hope, है ना? धीरे धीरे see we are going across the questions little by little. We are discussing the concept also. चलिए क्वेश्चन नंबर 20 पे चलते हैं. क्वेश्चन 20. अच्छा ये देखिए, इट्स ऑल्सो वेरी नाइस क्वेश्चन. टॉकिंग अबाउट पावर फैक्टर ओवर हियर. देखिए, पावर फैक्टर ऑफ द सर्किट शोन इन फिगर इज, ओके, समवन इज आस्किंग फुल सिलेबस का इंपॉर्टेंट है, 45 क्वेश्चंस है या 50? Yeah, the paper obviously has 45 questions only, right? Okay, so if you see this question based on the AC chapter, right, alternating current chapter, so here obviously you have to draw the phasor diagram. ठीक है? Resistance and the two reactances are also given to you, right, across the capacitor, and this one for the inductor, inductive reactance. ठीक है? And we have to find the power factor. Power factor is what? Power factor is given to you as cos phi. Cos phi. अब phi क्या है यहाँ पर? I will tell you in a bit. So remember these values, right? 80 ohm, 40 ohm and 100 ohm. ठीक है? So let's draw the phasor diagram over here. So remember, this is your resistance, inductive reactance, and obviously inductive reactance is much higher, right, than the capacitive reactance. Okay, so if you want, I will draw it a much bigger line like this, and this is your capacitive reactance. Let's finish it off over here. Okay, let's write the values. R is 80 ohm, that is 100 ohm. Capacitive is 40. Okay, now if you see, they are both opposing each other, right? So how do you find the net, that is the impedance of this circuit? How do we find it? See which one is bigger, XL or XC? XL is bigger, right? So the net of these two, the net of these two, that is 100 minus 40, that will become 60, and 100 minus 40 will become 60, and that will be in the upward direction like this, isn't it? So if I have to show it over here, it will become something like this, okay? Right? This, remember, is what? Is your XL minus XC, right? And this, remember, is your R. R is R only. There is nothing to support or oppose over here on this line. Hai na? So how do we find the total? Similar to vector addition we did in motion in a plane chapter, right? Using the parallelogram law. This, my dear friends, is going to be the impedance Z. We can calculate using Pythagoras theorem also. Acha. But here, remember, we are supposed to find the power factor. Power factor is phi, and which one is phi over here? Phi, ध्यान रखिए, this is the phi. Okay, this is the phi. So we have drawn the phasor diagram. Okay, and we can find phi also, rather cos phi also we can find. अच्छा, cos phi के लिए क्या चाहिए हमको? If you look at this right angle trigram, cos phi, this is phi, right? Cos theta is base by hypotenuse. Base is R only, hypotenuse is Z. So cos phi will become R by Z. Okay. Now R we already know, R is 80. How do we find Z? Using Pythagoras theorem, right? Hypotenuse is under root perpendicular square plus base square. So that will become, can substitute the values over here, 80 upon under the root 80 square plus 60 square. Okay. This, if we solve for it, this will become root 100 square. Root 100 square is 100 only. So it becomes 80 by 100. 80 by 100, that is 0.8. Okay, so 0.8 is our answer. And if we look at the options, it's going to be option 3. Okay. And my dear friends, कुछ और चीजें भी we can find if you want, right? That is potential drop कितना है हर एक के through, है ना? Potential drop. ध्यान रखिए, this voltage has been given to you over here. अच्छा, ये voltage कौन सा voltage है? Is it peak voltage or RMS voltage? तो ध्यान रखिए, if it is not given in the expression of sign, right? It's simply written as 220 volt. This is going to be your RMS voltage. We can also find RMS voltage across each of them. ठीक है? Each of them we can find. वो कैसे निकलेगा? Pretty simple. Z निकल गया, right? Z निकल गया. So what you do? VRMS upon Z. निकलेगा current. उस current को you multiply it with this, you will get voltage across XC. Multiply with this, voltage across R, and if you multiply current with this, you will get voltage across inductor. ऐसे 3 voltage मिल गए. And remember, those 3 voltages are RMS voltages. They are not peak voltages. Okay. Anyway, so इस क्वेश्चन का आंसर है 0.8. चलिए चेक करते हैं. And yeah, 0.8 is correct. चलिए अगले पे चले. क्वेश्चन नंबर 21. इट्स अ वेरी सिंपल क्वेश्चन. देखिए, बेस्ड ऑन ट्रांसफार्मर. ट्रांसफार्मर देखिए क्या कह रहे हैं. 100 टर्न्स इन द प्राइमरी कॉइल and carries 8 ampere current. ठीक है? So 100 turns in the primary. So this is given to you as NP. ध्यान रखिए. 8 ampere current. ये भी क्या है? Current in primary. If input power is 1 kilowatt. अच्छा. Input power. How do we find power? Power is given to you as I into V. I through primary we already know. Power also we know. है ना? So you use this formula, IP into Vp is equal to power. Power is how much? 1 kilowatt. That is 10 raised to the power 3 watt. Right? So how do you find Vp from here? Vp is nothing but 10 raised to the power 3, that is 1000 by current through primary. Current through primary कितना है? 8 ampere. This becomes 8. Okay, so 1000 by 8. So 1000 by 8 volt. Alright. If you want, you can solve further and write 125 volt also. Okay, so shall we write 125? Let's write 125. Okay. Alright. Then number of turns required in the secondary coil to have 500 volt output is. अच्छा, यहाँ पे देखिए, यहाँ पे they have already given the potential difference across the secondary coil, that is voltage output they have given, है ना. तो ये क्या है ये? This, my dear friends, is voltage across secondary, that is given to you as 500 volt. ठीक है. So primary से बहुत बड़ा है secondary. ठीक है, for this transformer. अब if you see this diagram, which transformer is it? क्या बता सकते हैं? Look at the diagram carefully and tell me. Right? Look at the diagram carefully. क्योंकि remember, number of turns we don't know, है ना. Primary में पता है, secondary में we don't know, but we know the potential difference across the two. We know the potential difference, है ना. So as you can see, we are calling this one a step down transformer, क्योंकि obviously number of turns तो कम है ही, number of turns in secondary are less, और जो potential output है that is also less. ठीक है. Therefore here for this one, this potential across secondary is less than potential across primary. उसी के कारण number of turns across secondary भी कम आता है. Whereas over here step up transformer, देखिए number of turns बढ़ गया, primary से बहुत ज़्यादा है यहाँ पर, right? That is in secondary you have number of turns higher than primary. So therefore जो potential drop है वो भी बड़ा है. अच्छा, वो कैसे पता potential drop बड़ा है? देखिए यहाँ पर, देखिए ये curve देखिए, ये बहुत छोटा है, वहाँ पे बहुत बड़ा है. That is again we are talking about the potential output, है ना. तो across the secondary coil, that V secondary is greater than V primary. ठीक है. So if you go back to the question, obviously secondary जो है बड़ा है 500 and primary is 125 volt. So it's bigger secondary. Therefore what we are talking about is this one. ठीक है. Step up transformer we are talking about. ठीक है. And what is the connection between these? क्या connection है? इनका ratio same है. इनका ratio same है. कैसे? देखिए. Let's finish off the answer over here itself. ठीक है. देखिए Vs by Vp is equal to Ns by Np. ठीक है. Let's substitute the values. Vs by Vp कितना है? 500 by 125. It comes out to be 4. So Vs by Vp is 4. Ns by Np, Ns we don't know. Np we know. Np कितना है? 100 turns. Right? So therefore Ns कितना आ गया? Ns comes out to be 4 into 100. 400 turns. ठीक है. So the answer, my dear friends, is option 3 over here. ठीक है. So I hope diagram के जरिए you have to remember the diagram. What is meant by step down transformer, step up transformer. तो ये जो है हमारा step up था. ठीक है. So yeah, it was 400 turns, right? That's what we got over here. Yeah, 400 turns is the answer. चलिए, question 22, again a very simple one, a straightforward one rather as well, right? ये देखिए what it says, the Maxwell equation, है ना, Maxwell equation, line integral of B dot dl, है ना, across that loop, ये क्या आ रहा है देखो, mu naught I plus epsilon naught times d phi e by dt is a statement of. ठीक है. तो सबसे पहले remember and understand the terms. ये I क्या है? This I what we are talking about, this I remember is your conduction current. ठीक है. Usually we also denote it by IC also. Okay. Whereas here this one, ये क्या है? ये क्या है? This is your displacement current. ठीक है. Denoted by ID. और ध्यान रखिए IC, remember we are talking about a capacitor, है ना, a capacitor. ठीक है ना. So between the plates of capacitor, there is no wire. There is no wire. What do you have? You have some medium, let's say air or some other, let's say dielectric or any other medium. So through that medium, since there is no wire, which current we are talking about? The displacement current. Displacement current, ठीक है ना? So that is directly connected to, as you can see, the flux due to electric field. Flux due to electric field. So if electric field is time varying, right, it will easily lead to displacement current, right? Because electric field is time varying, it will lead to the flux, the electric flux being time varying. So d phi by dt, it will come out to be non-zero, and thereby you are getting some displacement current between the plates of capacitor. ठीक है? और जबकि आपका जो conduction current है, where is that one? Conduction current तो आपका wires में है, that is over here. ठीक है? Whereas displacement current, my dear friends, is over here. Okay, so I hope you understand, right? So this is a direct statement from your modified Ampere's law. All right, this is what we studied in the electromagnetic waves chapter as well. Okay, so it is not Gauss law of magnetism, because Gauss law of magnetism says integral B dot ds is equal to 0, right? It is not Gauss law of electrostatics also. Gauss law of electrostatics says integral E dot ds, that is the total electric flux through a closed surface that we already talked about, है ना? That is equal to charge enclosed by epsilon naught. This is also wrong. Both talking about flux, right? This is the law, that Maxwell equation we are talking about. And Faraday's law of EMI, obviously that is also wrong, right? Faraday's law, what does it say? That is the induced EMF, right? Induced EMF is given to you by minus d phi by dt. Okay, so option 2 is correct. Let's check, and yeah, so option 2 is our answer. चलिए क्वेश्चन नंबर 23 पे चलते हैं. चलिए करें क्वेश्चन 23. ये देखिए क्या कह रहा है. इन यंग्स डबल स्लिट एक्सपेरिमेंट YDSC, राइट, स्लिट सेपरेशन इज मेड 3-fold, द फ्रिंज विड्थ बिकम्स. ये अच्छा डायरेक्ट क्वेश्चन है ना. फ्रिंज विड्थ का फॉर्मूला आपको पता होना चाहिए. फ्रिंज विड्थ क्या फॉर्मूला है? फ्रिंज विड्थ इज डिनोटेड बाय बीटा यूजुअली, है ना. फ्रिंज विड्थ का क्या फॉर्मूला है? You can remember this one if you want, है ना. Lambda d by small d, ठीक है, where lambda is the wavelength of, let's say, the monochromatic light we are using. D क्या है? The separation between the slits or the screen, ठीक है, and small d obviously is your slit separation. So slit separation is made 3-fold, fringe width will become, they are asking, है ना. So this screen separation, it remains the same. The separation between the screen and the slits remains the same. Capital D, lambda भी वही है, but D we are affecting. So beta, remember, is inversely proportional, na. So if D becomes 3 times, beta will become 1/3 times, right? So we can say beta dash क्या हो जाएगा? Beta by 3, right? That is 1/3 times it will become. That's it. Pretty simple. If you want, you can directly conclude from here also. Okay, it becomes 1/3 times. All right, so let's check. And yeah, the answer is correct, है ना. So remember, NEET में बहुत सारे सवाल they are direct. If you remember the formula, you're able to do it easily, है ना. Pretty much we can also comment about कि position of क्या होगा. Position of first maxima, second maxima, first minima, second minima, है ना. Slit separation को ये कर दिया. So what happens to those positions? Positions with respect to the central maxima, है ना. Position with respect to the central maxima. So that has to do with your fringe width. और fringe width आपका affect हो रहा है, so that position will also be affected. Okay. Okay. Moving to question 24. ये देखिए, it's also very simple, है ना. Dual nature topic से है. Assertion says, in photoelectric effect, increase in intensity of light increases the photocurrent. ये सही है कि गलत है? ये सही है कि गलत है? देखिए, you have to remember the 3 graphs, right? 3 main graphs that are given under the study of photoelectric effect, right? Before, if you see the Einstein's photoelectric effect equation that is written, 3 graphs have been drawn in your NCERT. So please go through them. One of those graphs talks about this assertion, right? That is, intensity is directly proportional to the photocurrent. ठीक है, that is if you increase the intensity, photocurrent will also increase. If you double the intensity, photocurrent will also get doubled, provided the photoelectric effect is taking place. ठीक है, ये तो बिल्कुल सही है. Second one says at stopping potential photocurrent is 0. ये बताइए at stopping potential photocurrent is 0. अच्छा, stopping potential what is it? First of all देखिए, in that photoelectric experiment है ना, आपको जो कैथोड है, you have the photoelectrons that are ejected from it and they are trying to reach the anode, है ना. आपने एक stopping potential लगाया, right? Stopping potential what is it? It is the minimum potential at which so it is the minimum potential that is provided to stop the photoelectrons. और वो भी कौन सा photoelectron? The photoelectron that has been ejected with the maximum kinetic energy. ठीक है, so that minimum potential is called stopping potential और उससे photocurrent obviously is going to be 0 because if the photoelectron with the maximum kinetic energy is stopped, obviously all the rest of the photoelectrons that have been ejected from the metal surface, they are also stopped, है ना. So photocurrent is obviously going to be 0. ठीक है, लेकिन इसका इससे कोई लेना देना नहीं है, right? Reason has nothing to do with the assertion. So therefore we say both are true, but reason has or is not the correct explanation of assertion. Okay, so I hope it is clear, right? Either way, changing the potential, it has nothing to do with the intensity. And similarly, changing the intensity, it has nothing to do with the stopping potential. That way also you can remember. Okay, let's check. तो ऑप्शन 2 इज करेक्ट. चलिए, तो क्वेश्चन 25वें पे चलते हैं. इट्स अ वेरी सिंपल क्वेश्चन. ये वन बी देखिए, प्योर सेमीकंडक्टर इज नोन एज, प्रीटी सिंपल राइट? एक्सट्रिंसिक, इंट्रिंसिक, एन टाइप और पी टाइप. इट्स ऑब्वियसली इंट्रिंसिक. प्योर, प्योर एज इन हमने कोई डोपिंग नहीं किया, वी हैव नॉट एडेड एनी इम्प्योरिटीज, एनीथिंग, राइट? एन टाइप सेमीकंडक्टर, यू ऐड सर्टेन अमाउंट ऑफ a certain type of impurity, p type भी दूसरा type of impurity, और इन दोनों को actually कहते हैं extrinsic semiconductor. So all these three options are eliminated. They are not pure anymore. The only pure one is intrinsic. ठीक है, देखिए, let's check. हाँ जी, option 2 is correct. चलिए, क्वेश्चन 26. क्वेश्चन 26 देखिए, it's also a very simple one, है ना. ये देखिए क्या कह रहा है, रीड द स्टेटमेंट्स एंड सेलेक्ट द करेक्ट ऑप्शन. स्टेटमेंट 1 इज सेइंग एवरी ऑसिलेटरी मोशन इज अ पीरियोडिक मोशन. ये सही है कि गलत है? ये सही है कि गलत है? या दिस इज ट्रू, राइट? दिस इज ट्रू. एवरी ऑसिलेटरी मोशन इज पीरियोडिक. फर्स्ट ऑफ ऑल, व्हाट इज ऑसिलेटरी मोशन? ये आपको यू नीड टू रिमेंबर, राइट? सो रिमेंबर, ऑसिलेटरी मोशन क्या है? You can remember it like this, to and fro motion, है ना? To and fro, इधर से इधर, इधर से इधर, something like simple pendulum, है ना? It's oscillating about its mean position. So yes, it is going to be periodic, no problem with that. But the statement 2, that's problematic. Every periodic motion is oscillatory. ये बिल्कुल गलत है, ये बिल्कुल गलत है. ऐसा क्यों? एक एग्जाम्पल बताइए जब नहीं होगा ये, है ना? बिकॉज पीरियोडिक में क्या है? पीरियोडिक मोशन, राइट? रिमेंबर दैट द मोशन रिपीट्स आफ्टर ए स्पेसिफिक टाइम पीरियड, है ना? सो आई विल राइट, लेट्स से मोशन रिपीट्स आफ्टर टी. टाइम पीरियड टी है, लेकिन उसका एक ये वाला देखिए, जो यूनिफॉर्म सर्कुलर मोशन है ना, यूनिफॉर्म सर्कुलर मोशन इफ यू सी it's moving like this in a circle, है ना, but this we cannot call it oscillatory motion, right, because oscillate is to and fro. There is no to and fro over here, nothing, because it's completely moving in a circle, right. So this is periodic motion, but it is not oscillatory. So please remember, right. So this we say is not oscillatory, but still periodic. Okay, so this is wrong. So statement 1 is true, 2 is wrong. So therefore option 3 is correct. Only statement 1 is correct. Okay, चलिए चेक करते हैं. Yeah, so it is correct. चलिए क्वेश्चन नंबर 27 ये देखिए. It's also a very simple question, है ना. The moment of inertia of a uniform rod of length L and mass M about an axis passing through point A and perpendicular to length of rod is. ठीक है, length of rod अगर center of mass से pass करे that axis, right. If the axis were to pass like this, what is the moment of inertia, right? We already know the formula, right? ml square by 12. But here if you read, they are saying the axis passes through point A. This axis is perpendicular, but here they are saying this is the axis, है ना. इसका तो हमको याद है already. It has to be ml square by 3. Mass is m, length is l. ml square by 3, right? 1 is the answer. अच्छा. Now how do we get this ml square by 3? Using which theorem? Parallel axis theorem, right? So let's say if I were to call this as ICM, right, and let's say this I am calling it as I dash, ठीक है, and let's say distance between these two axes is d. So what will I dash become? I dash is ICM plus md square, ठीक है. I am also showing you the derivation, but if you remember you could have directly taken the answer. ICM कितना है, देखिए ml square by 12 m into d. Now what is d over here? Remember the total length is L, d is half of it, that is L by 2, right. So this becomes L by 2 whole square. So therefore ml square, if you want you can take it as common, right. Inside you have 1 by 12 plus 1 by 4. Okay, take LCM. This will become 3 by 12. Therefore this whole becomes 4 by 12, and 4 by 12, my dear friends, eventually leads you to ml square by 3. Okay, this we already take the answer. ठीक है. So remember the method. किसी भी एक्सिस के थ्रू हम पूछ सकते हैं. Alright. चलिए let's check. जी हाँ, so option 1 is correct. Yeah. चलिए अगले पे चले. Question 28. ये देखिए, what is it saying? A charged particle Q is moving with uniform speed v, enters in a region of uniform magnetic field B and normal to the field. The path traced by the circle is. This also you can remember, है ना. आपका जो helix और circular path वाला जो topic है under moving charges and magnetism, है ना. ध्यान रखिए. So let's say this is your magnetic field like this. Okay, magnetic field lines are all like this, right? And let's say they are present in a region and charge is entering this region. Okay, so what happens if let's say charge is entering, charge is Q. Okay, charge is entering like this with speed v, making an angle theta with the uniform magnetic field. Okay, theta, right? So what happens if theta is 0? So these three cases you can remember. If theta is 0, that is velocity is along the direction of magnetic field, है ना. Velocity is along the direction of magnetic field. तो यानी कि वो क्या हो जाएगा? Force क्या हो जाएगा? Force is equal to q v cross b, isn't it? तो v cross b क्या हो जाएगा in this case? V and B are in the same direction, है ना? So VB sin theta, theta is 0, so VB sin 0, force is 0. If there is no force, therefore that charge will continue to move in the same direction, right? So it will trace a straight line, right? So it will move in a straight line path, okay, because force is equal to 0. Acha. What happens if, let's say, theta is less than 90 degree and theta is more than 0? तब क्या होगा? That is this diagram, है ना? क्योंकि थीटा बड़ा है, कुछ वैल्यू है 30 डिग्री, 60 डिग्री, 40 डिग्री, whatever. So in that case, you will have two components of velocity. One component of velocity will be along the same direction as magnetic field. Another component will be perpendicular to the magnetic field, है ना? अब उस component that is parallel to the magnetic field, the charge will move forward because of that component. There is no force because of that component. But what about the component of velocity that is perpendicular to magnetic field? जो perpendicular है उसके कारण क्या हो जाएगा? VB sin 90 डिग्री, यानी कि force कुछ आ जाएगा. That force will be perpendicular to velocity and magnetic field, right? It will be perpendicular. That means the charge will now start moving in a circle, because what happens when force is perpendicular to velocity? We saw in the second question today. जब acceleration perpendicular है ना, centripetal acceleration we call it. So charge is moving forward, charge is also moving in a circle. So therefore the path is what we call helical path, or it traces a helix. Okay, it traces a helix. We can, or let me write it and leave it like this. Now what happens when theta is equal to 90 degree? Which is that case we discussed over here, है ना? Question में क्या कह रहे हैं देखिए, it enters a region of uniform magnetic field B and normal to the field. Normal meaning that V vector is perpendicular to B vector. That is, this theta will become 90 degree. When theta is 90, V is perpendicular, na? So if we calculate the force, it will become QVB sin 90 degree. Force will be there. So only force you are getting is the centripetal force, and obviously the charge, we won't say there is no, there is a component of velocity along the direction of magnetic field, na? So it's going to perform circular motion. The charge is going to perform circular motion. So there is no helix formed over there. So it is going to trace a circle, right? It's going to trace a circle. Okay. So if we come over here, the path is going to be circular path. Okay. Helix is wrong, straight line is wrong, है ना? Straight line when theta is 0, helix when theta between 0 and 90. Here obviously not the case. Parabolic obviously is wrong. So circular path is the answer. All right. Moving to question number, next one now. This is correct. Question 29. Right. Read this question. What it says? It says two polarizers have their axis inclined at 45 degree to each other. If unpolarized light of intensity I0 is incident on the first polarizer, then the intensity transmitted to the second polarizer is. So note the keyword unpolarized light of intensity I0. Right. So let me draw a rough diagram, something like this over here. Huh? This is, let's say, the first polarizer, right? And then the second polarizer over here, remember they have said it is inclined at 45 degree, right? So I will draw it, let's say, like this only. Okay. It's actually inclined in that plane, all right, in that plane. So you have to think about it visually, all right. But if you want, I can write over here inclined at theta equal to 45 degree. All right. Now initially, what is the light that is entering? Your unpolarized light, right? Unpolarized light meaning you have vibrations in all directions. Okay, and let's say the initial intensity is I naught as given to you over here, right? So initial intensity is I naught. All right. After entering the first polarizer, it will become polarized. Okay, so this remember is your unpolarized light. Intensity is I naught. Now here after passing through first polarizer, it will become polarized light. Okay, but the intensity will become and reduce by half. So if it is I naught initially, after passing through polarizer, it will become I naught by 2. Okay, so it will become I naught by 2. Now passing through the second polarizer, if it is inclined at theta, which law do we use to find out this intensity I dash over here? That law is called your Malus law, right? Right. So what is the intensity going to be? The initial intensity before entering this polarizer, that is I naught by 2 multiplied by cos square theta, okay, where theta is 45 degree. So that's it, you got the answer. Now all you have to do is substitute the values. So if you substitute it over here, this will become I naught by 2 into cos 45 degree. Cos 45 degree is how much? 1 by root 2. So 1 by root 2 whole square. Okay, 1 by root 2 whole square is also 1 by 2. 1 by 2 into 1 by 2 will become 1 by 4. So this is I naught by 4 is our answer. Okay, so if you check, I naught by 4 is our answer. Right? We can check the answer as well. So please remember the diagrams and the Malus law that we have used over here. There was no need to use the Malus law over here because it was initially unpolarized only. Acha, first let's check the answer also. Yeah, it is I naught by 4. Coming back, one more question could have been asked over here, right? Please focus. So let's say, what if they had said initially the light is polarized, right? Initially if they had said polarized light of intensity I naught is entering. That means it is not like this. Remember the diagram I have drawn it like this, that is the vibrations in all directions, because it is not polarized in a particular direction. That is why, right? So if it is polarized and having intensity I naught, then after passing through first polarizer, it is going to be I naught cos square theta. So here also you have to apply that formula. Okay, where theta is the angle between this vibration, right? This direction of vibration and the direction in which the Polaroid has been placed, right? The angle between the two. That theta, so you will write I naught cos square theta instead of I naught by 2. But here it's given initially unpolarized, that is why we have directly written I naught by 2. Okay, I hope it's छोटी सी चीज़, I hope you guys have understood. Okay, moving to question 30 now. Question 30, very simple, this one. Two thin lenses of powers P1 and P2 are in contact and they are coaxial as well. Contact, right? They are both touching each other, both lenses are like this. Okay, the focal length of the combination is. So remember the same formula which you already studied in your 10th class also, right? So what is the total power? How do we find if let's say 3 lenses, 4 lenses, they are all in contact? All we have to do is just add their powers, that's all. So for the combination, power of the combination is nothing but P1 plus P2, right? Now what about focal length of the combination? Remember, power of combination and focal length of combination, how are they connected? They are inversely related to each other, right? So power of combination is nothing but 1 by focal length of combination. Right? So therefore, what is focal length of combination from here? This is going to come out to be, take this over there, P1 plus P2 over here. It is 1 by P1 plus P2. See, direct straightforward question. This one was, right? So option 4 is our answer. Okay. And obviously in the question, if let's say these powers and their values were also given, let's say power values were 3D, as in 3 diopter or 4 diopter or minus 4 diopter, if those values were given, then after adding them up, we could have commented about how that combination is, whether that combination is acting like a concave lens or a convex lens, etc. etc. But anyway, here nothing is given, so this became a straightforward question. ठीक है ना, बहुत आसान था ये. चलिए अगले पे चले. Yeah, this is correct. Question 31. Question 31, ये भी pretty straightforward, right? उसको आपको वो formula याद रखना है. From your nuclei chapter, this one is, right? If radius of aluminum nucleus is taken to be this, then radius of this nucleus, right? This I believe is tellurium, right? Tellurium nucleus is nearly. इसके लिए which method we are using? Use that formula, that is density of nucleus remains constant. Right, so density of nucleus remains constant. Why? Because the radius of nucleus, it varies like this. R is equal to R naught, 8 to the power 1 by 3. Right, where R naught is your constant, that is 1.2 Fermi. Right. Remember this R naught is actually 1.2 femtometer or Fermi, where A is your mass number. Okay, and obviously you have 1 by 3. Right, so R is proportional to 8 to the power 1 by 3. That also you can use. And A, my dear friends, what is A? A is the mass number. How do we find the mass number between these two numbers, 13 and 27? Which one is the mass number? This 27 is the mass number, while the lower written numeral 13 is actually your atomic number. Okay, so we use that formula. R is proportional to 8 to the power 1 by 3. Okay, so what do we do? See, we can take the ratio of, we have two nuclei, right? Aluminium and Te. So I am writing it like this. Radius of aluminium by radius of Te is equal to ratio of their mass numbers, that is mass number of aluminium upon mass number of Te whole to the power 1 by 3. So you can substitute the values. For aluminium mass number is 27 है ना, 27, or here 125. So if you substitute whole to the power 1 by 3, right, and you can take the cube root also. Cube root of 27 is how much? 3, and cube root of 125 is actually 5, right? 5 into 5 into 5 is 125. And we have to suppose to find the radius of this Te, right? So we can write radius of Te nucleus is nothing but take 3 and 5 this side to the LHS. So it becomes 5 by 3 radius of aluminium. That's it. Pretty simple. This one was right. So if we can check the options, this is wrong. Right? It's written 53 by 13. Completely irrelevant and ridiculous option. This one is, isn't it? By seeing the option itself, you could have eliminated. Right? Similarly, this one is also wrong. Correct one is option 2. And while obviously option 4 is also wrong. 3 by 5. Right? So yeah, option 2 is correct. Let's check the answer. And yeah, option 2 is correct. Okay, and one more thing you guys can note down. Here we have found the radius of this Te nucleus. Similarly, if for this nucleus volume were given VAL, you could have found the volume also. How? Instead of taking ratio of radii, you could have taken ratio of volume. So volume ratio will become, volume is proportional to R cube. Volume proportional to R cube, and R cube will be proportional to A. Right? If you do cube over here, it will become A. So volume is proportional to A only. So the ratio of their volume is simply ratio of their mass number. ठीक है? चलिए 32वें सवाल पे अगला. Let's check that one. Okay. See this question. talking about a radioactive reaction. है ना? If you read, in a radioactive reaction, alpha and beta minus particles are emitted. ठीक है? X nucleus is becoming Y nucleus. The number of alpha particles emitted are. अच्छा, alpha particle होता कैसे है? ध्यान रखिए, उसका atomic number है 2, mass number है 4, है ना? तो याद कि when alpha particle is emitted, atomic number will decrease by 2 and mass number will decrease by 4. Okay, now what about beta minus? Beta minus का कोई mass number है? नहीं है. But when beta minus is emitted, atomic number will increase by 1. So that you need to remember, है ना? For alpha and beta minus. So for beta minus, there is no decrease in mass number. यानी कि whatever mass number reduction is happening, that is only due to alpha particle only. और एक alpha particle के लिए mass number reduction is how much? 4, right? And how much, if you see over here, how much the mass number is reducing? By 232 minus 220, na? It becoming or reducing by 12, right? So I can write number of alpha particles is actually equal to, see the decrease, how much? 232 minus 220, है ना? But for one alpha particle decreasing by 4, so you have to divide it by 4. So this becomes 12 by 4, that is equal to 3. So 3 alpha particles should be emitted. अच्छा, now आप सोचिए, if 3 alpha particles are emitted, जो atomic number है, it has to decrease by how much? अब देखिए, let me write down over here, है ना? तो 3 alpha particles, right, and let's say n beta minus particles. ठीक है? अब देखिए how I am doing. Just one line, I am going to write only one line equation and you will get the answer. What is the original atomic number? 92. Okay. Now if 3 alpha particles are emitted, atomic number reduction will happen by how much? 3 into 2, that is 6. Right? So minus 6. Right? So I hope you understood how. No? What I did? 3 times 2. Now for n beta minus particles are emitted, atomic number will increase by 1 for each. So here grand total, it will increase by n. This would be equal to the final atomic number. Final atomic number is how much? 88. Right? That's it. So all you got to do is solve this equation. So if you solve it, 92 minus 6, this will become 86. 86 plus n equal to 88. So n is equal to how much? 88 minus 86, that is equal to 2. So therefore 2 beta minus particles are emitted and 3 alpha. That's it, you got the answer. And anyway, they were asking only number of alpha particles. Yeah, someone has commented 3 alpha. Yes, you are correct. So option 4 is the correct answer, right? Let's check. I hope this was easy, right? Option 4 is correct. Yeah. I hope everyone is clear, right? Let's move further. ठीक है? चलिए 33 पे चलते हैं. Read this question. It's also a very simple question, है ना? Correct representation of graph, उसका variation, कौन versus कौन देखिए, of graph between angle of deviation delta and angle of incidence I for a triangular prism. ठीक है? You have a triangular prism like this. Incident ray is incident on one side, it is emerging on the other side. You are finding angle of deviation between both rays, that is delta. You are plotting a graph between delta and I. So which is the correct graph that you are supposed to find? Right? So obviously this is wrong. है ना? It says no matter what I, delta remains the same. This is wrong. This one if you see, this is also wrong. If you keep on increasing I, delta also keep on increasing. This is wrong. We have studied that this angle of deviation achieves a minimum value for a certain angle of incidence. For a certain angle of incidence, right? Obviously, in which graph it achieves a minimum value? This one only, right? Because if you see, So for this angle of incidence, let's call it theta. Correspondingly, you have an angle of deviation over here, that is delta minimum. Okay, and this is the delta minimum. Now if you see, for any other angle of incidence, right, let's say, so obviously this is the correct answer. We are now discussing the graph. Okay, so let's say I am taking any other angle of incidence. Let's say I am taking over here. Let me draw it like this. Let's say over here I am taking, right, this is, let's say, I1. For this one, what is the angle of deviation? This is the angle of deviation. Let's call it delta. But if you see carefully, this delta is also corresponding to this angle also. This angle also. So what is this angle then? This is, let's say, I2. Right? So remember, for two angles of incidence, you have the same angle of deviation. How come? How come? Because remember the formula for angle of deviation. Right? So what is the formula? For angle of deviation, delta is given to you by I plus E minus A. Right? For a triangular prism, where here remember these are the I1 and I2 I am talking about. Right? So I write I1 plus I2 minus A. Okay? So for that prism, if this is the I, then this will be the, if this is the angle of incidence I, then this will be the angle of emergence E. Or if this is the angle of incidence, then this will be the angle of emergence E. Okay, so I hope you guys understood what I am trying to say. If this is I, this is E. If this is I, this is E. Alright, and thereby you have the same angle of deviation. So these ways you can remember which graph is it. Okay. Let's check. And yeah, option 2 is correct. चलिए अगले पे चलते हैं, क्वेश्चन 34 है ना. क्वेश्चन 34 बहुत ही स्ट्रेट फॉरवर्ड सवाल है. द यूनिट ऑफ मैग्नेटिक फील्ड है ना, एंड इफ यू सी द ऑप्शंस, it's all given in terms of Weber, Weber, Weber. Now what is Weber? Weber is also an SI unit. SI unit of who? It is the SI unit of magnetic flux. Okay, and magnetic field, my dear friends, B, and magnetic flux, how are they connected? Because magnetic flux is given to you like this formula, na? B dot A, right? Dot product of magnetic field and the area vector. So we can say magnetic field, it's actually given by, if it's, let's say, equal to BA. Okay, so magnetic field magnitude is given by phi upon A, right? So unit of magnetic field is nothing but Weber per, right? If this is, let's say, Weber, in unit of area is meter square, isn't it? So therefore the unit of magnetic field can be written as Weber per meter square. Pretty straightforward. Okay. Either way, the SI unit is Tesla, that you guys already know. In this way also we can write the same thing. Let's check. जी हाँ, so option 2 is correct. ठीक है? So I hope it's clear so much, right? चलिए अगले पे चलते हैं 35वें सवाल पर. Let's read this one. Energy required to establish a current of 2 ampere, है ना? Current of 2 ampere in a coil of self inductance L is equal to 400 millihenry is. So energy, है ना? Energy का क्या formula है? Energy with regard to inductor, right? That energy is given to you by simply half L I square. Okay, simply half L I square, right? And everything else is written already. So it's a very, very direct question, this one, right? And energy required is what we are supposed to find in terms of joule. So let's substitute. Half L कितना है आपका? 400 millihenry, है ना? So 400 into 10 to the power minus 3. ठीक है? into I square. I कितना है 2 ampere. So 2 square will become 4. Okay. So this, if you solve for it, 4 into 4, 16, right? So 16 by 2, 8. And here obviously it will become 1 by 10, right? 100 into 10 power minus 3 becomes 10 power minus 1. So this becomes 8 into 10 raised power minus 1, that is 0.8. 0.8 joules. Okay? We got the answer? Okay? Let's check. Yeah, so 0.8 is correct. चलिए अगले पे चलते हैं क्वेश्चन नंबर 36 पर. Let's see question number 36. Read this one based on screw gauge. It's a very simple question, right? देखिए पढ़िए. देखिए, please read. If a screw gauge has a pitch is given to you 1 millimeter and 100 divisions on circular scale, right? So pitch, let's say I'm calling it as P. Number of divisions I'm calling it as N. Okay. Which of the following reading can be made from this screw gauge? Which reading can be made? So if you see the options even before solving the question, right? So if you see this option, right, there are 3 places after decimal point, here also 3, here it is 2, and here it is 4 places after decimal point, right? So when someone asks you which reading can be made using that instrument, they are asking you to focus on the least count of that instrument. Okay? So for example, if this reading has to be made, what has to be the least count? Least count has to be 0.0001 millimeter. Okay, likewise and henceforth. So first let's find out the least count of this screw gauge. Okay, so I can write that is given to you by the pitch divided by the number of divisions on circular scale. Okay, that's it. So if you see over here, pitch is 1 millimeter, that is 100, right? So this will become 1 millimeter by 100, that is 0.01 millimeter. So this has to be the least count of the reading also, right? So if the reading is given to you 0.001 millimeter, that reading is impossible because our instrument has to have this least count 0.01 millimeter. And if you check the options, right, this is wrong, this corresponds to 0.001, this is also wrong, 0.001 millimeter, this is correct, this corresponds to 0.01 millimeter. Well, this obviously is wrong. Okay, so option 3 is correct. Okay, so please understand, as per least count we have done this question. Okay, let's check. So yeah, the third reading can be made from this screw gauge. Okay, so let's come to question number 37 now. चलिए अगले सवाल पे चलते हैं 37. ये देखिए, what is it saying? A capacitor is in series with a resistance of 30 ohm and is connected to 220 volt AC line, right? So both capacitor and resistor, they are in series. Okay, now the reactance of capacitor they have given 40 ohm, resistance is also given 30 ohm for that resistor. What is power loss in circuit nearly, right? So please remember the formula for power loss in circuit. The power loss is given to you by, right, or if you want, let's write it on the next page. Is given to you by Vrms IRMS into power factor, which we already did, right? Power factor is cos phi. Okay. There is also another formula of the same. Vrms, if you were to write it in terms of peak value, so it becomes V peak by root 2. This is I peak by root 2. So therefore, that formula will become V peak I peak into cos phi, but whole upon 2, right? Whole upon 2. Okay, so I hope you understood how we got 2, right? Root 2 into root 2 will become 2. Okay, so if we come back to this question, 220 volt AC line. So Vrms is given to you, right? Vrms is given to you as 220 volt. Resistance R is given to you as 30 ohm. Then reactance, as in capacitive reactance, is also given to you, right? 40 ohm. Okay, and we can find the impedance also, impedance of the circuit, right? How will the phasor diagram look like? Rough phasor diagram, if I have to draw, right? This is R, this is XC, right? So how will the Z be? Or if you want, we will write. This, my dear friends, will become the Z. Z is given to you as Pythagoras theorem, using Pythagoras theorem, just like we did over there. Use Pythagoras theorem from these two. Right, Z, what is it? Impedance. Okay, impedance Z is going to be given to you by under root this square plus this square. Right, so it is 30 square plus 40 square. That is 900 plus 1600, that is 2500 whole under the root. So this is going to become equal to 50 ohms as the impedance of the circuit. So Z we already know, right? And remember, the current I is going to be or can be represented over here, right? While the total Vrms for the whole circuit, right, that is given as 220 volt. That will correspond to some peak value, right? And that peak value can be represented along this Z. Or you can also say that RMS value is also represented along the Z, right? Remember, we are talking about the whole circuit. Okay, so we can say over here is your Vrms, right? Because Vrms obviously it's going to be much bigger, right? So if you want, I can draw it over here. This is your Vrms, right? And this, let's say, is your IRMS, right? And here obviously is your phi. Right, phi corresponds to the power factor, that is cos phi. All right. Anyway, those I'm talking about the phasor diagram. Right. This Vrms IRMS diagram, it's not needed. I just told you just for your information. Okay. And this, remember, is for the whole circuit. Okay. All right. Anyway, so Vrms we already know 220. Z also we know. So we can find the I. Right. We can find the I. So how will we find the current? I is given to you as Vrms upon Z. Okay, Vrms is 220, Z is 50, so this becomes 22 by 5 ampere. Okay, now cos phi. Now what is cos phi? Cos phi is nothing but base upon hypotenuse, right? So if you notice the original yellow color phasor diagram, hypotenuse is Z, base is R, so cos phi is R by Z. Cos phi is R by Z. So let's substitute all these values for the power loss. Okay, so power loss, if we substitute it over here, all we got to do is solve for them. Vrms is 220, right? 220, and IRMS is 22 by 5. Cos phi. Cos phi, as I said, R by Z, right? R is 30, Z is 50. So 30 by 50. Right, 30 by 50, that is 3 by 5. 3 by 5, right? So now you can solve for it. over here, right? This will become 5 into 5, that is 25, right? 25, if you want you can multiply numerator and denominator by 4. So this will become, just a minute, let me show you like this, 4 by 4, denominator will become 100, 25 into 4, 100. It will be easy to write decimal if need be, okay. And if you see over here, 22 into 22, that will become 484, right? 22 square, 484, and then you have a 10 also over here, then 4 into 3 will become 12, right? And obviously you have a 10 over here, okay, and this one you can cancel, 10 with 100, right? And these you have to solve, okay, these you can solve, 484 into 12 upon 10, okay, and you can check the answer also, right? These you can solve, everyone. Please take a try, okay, take a try, and can you tell me the answer? Come on, bataiye. Okay, so yeah, so if you try, right, I think you'll get the answer, right? I think it is option number 4, okay, 580 watt. Okay, so that was question 37. Moving to question 38 now, right? That was a simple calculation only. Obviously that question involved a lot more steps, right? And we also discussed a little bit about phasor diagram also. Okay, anyway, this question is one based on semiconductors, right? Current flowing through the resistance R is. Resistance R is, right? So obviously this, what we have shown over here is your diode, right? Where this is your P side and this is N side, okay. And if nothing is given, let's assume it to be an ideal diode, right? So if it is forward biased ideal diode, it will offer 0 resistance. If it is reverse biased ideal diode, it will offer infinite resistance, okay. So in this case, whether it is forward biased or reverse biased, how do we check? In the case of forward biased, higher potential has to be connected to the P side, okay. So higher potential, check which one is higher between -2 and -4. This is higher, while this is lower. Higher side is connected to P side, yes, it is a forward biased ideal diode. Therefore, we say it behaves like a simple wire, that is, it offers 0 resistance, okay. So replace this diode and connect a simple wire over here, right? And now we have to calculate the current through the resistor. How do we do it? Simple, Ohm's law, right? So what is the potential difference? So how do we calculate the current? Current is given to you by nothing but potential difference by resistance. Potential difference by resistance, right? So what is the potential difference? Higher minus lower, right? Higher minus lower. Obviously -2 is higher than -4, right? So the potential difference is going to be -2 minus of -4. It will become -2 plus 4. Resistance is how much? 100 ohm. So this is becoming 4 minus 2, 2 by 100. 2 by 100, that is 0.02 ampere, or in the options you can check only 2 ampere is given, so this is wrong. Resistor given in milliampere. So how do we convert it into milliampere? You would have to multiply this by 1000, okay. So 1000, this will become milliampere, okay, and these cancel out. So the answer is 20 milliampere, okay, and option 4 thus becomes our answer, okay, option 4. And obviously here I can also show the direction of current also, okay, yeah. So one person has answered 20 milliampere is correct. Acha, how is the current flowing? Higher to lower potential, right? So like this current is flowing. I, okay, like this. Okay, चलिए अगले पे चलते हैं 39. अच्छा ये देखिए क्वेश्चन नंबर 39. It's also a simple question. Self inductance of primary and secondary of perfectly coupled coils, perfect coupling, right, are 4 millihenry and 9 millihenry respectively. The coefficient of mutual inductance between them is, ठीक है, तो ध्यान रखिए mutual inductance is given to you by this formula K times under root L1 L2, but if it is perfect coupling that K will become 1, right, so we can directly write M is equal to under root L1 L2. That's it, we got the answer. ठीक है, अब बस इसमें वैल्यू सब्स्टिट्यूट करिए. 4 millihenry है ना, 4 into 10 raised to the power minus 3. Then you have 9 millihenry, 9 into 10 की power minus 3. This will become under root 36 into 10 raised to the power minus 6. That is nothing but root 36 is 6 and under root of 10 power minus 6 is 10 power minus 3. Right, so this becomes 6 into 10 raised to the power minus 3 Henry. That is equal to 6 millihenry. Okay. Option 4 is our answer, right? So under root of 4 into 9, so 6. So please remember, right? Only because of perfect coupling we have used this formula. Okay, so please keep that in mind as well. Perfect coupling. Okay, otherwise this would not have been the case. Okay. Acha, what happens if let's say there is no coupling between them? There is no coupling. Then that K will become 0. Therefore, M will also become 0. Okay. Okay, so let's check 39 and yeah, it's coming option 4. Okay. Read on question number 40. Almost last segment पे आ गए हम, है ना. ये देखिए क्या कह रहा है, in adiabatic change between system and surroundings. अच्छा adiabatic होता क्या है? Adiabatic, right? Isothermal क्या होता है? When temperature is constant. Adiabatic में there is no heat exchange, है ना? Heat exchange is 0, right? So we say Q is equal to 0. Q equal to 0. अब Q using first law of thermodynamics हम क्या लिखते हैं? It is equal to delta U plus W. Delta U is the change in internal energy और W क्या है? Work done, है ना. W क्या है? Work done. अच्छा चलिए हम पढ़ते हैं. Read the options. If you read the fourth option, it says there is fast transfer of heat as well as variation in temperature. ये तो गलत हो गया क्योंकि transfer of heat तो कुछ है ही नहीं, right? There is no transfer of heat. So if you want, I can write down no transfer of heat. Please keep that in mind. And if you see option 2 also is saying there is transfer of heat. So this is also eliminated. Only two options are there, 1 and 3, where they are saying there is no transfer of heat. But if you read them further, as in option 1 says there is no transfer of heat, hence temperature remains constant. This is wrong. How can we say temperature remains constant? Because remember, if temperature is constant, what will happen? If temperature is constant, right, that is delta T equal to 0, you will get delta U, that is change in internal energy, also equal to 0, right? But here we cannot say that. Just because adiabatic change doesn't mean temperature is constant, doesn't mean internal energy is 0. Okay, internal energy may increase or decrease also depending on the work done. Okay, and that is what option 3 is saying. There is no transfer of heat, but temperature may vary. Okay, clear? I hope this is clear to you now. Alright, so option 3 is our answer, right? So please remember, it may increase or decrease. चलिए check करते हैं, and yeah, option 3 is correct. Shall we move to the next question? देखिए, this one is a match the column type question. देखिए, पढ़िए. When a body is moving vertically up with constant velocity. अच्छा, दो चीज़ें, moving vertically up और velocity भी constant. Velocity constant meaning the acceleration is 0, right? Acceleration is 0, right? Let's read on. Match the following, है ना? So work done by lifting force, यानी कि body is moving up. Let's say gravity जो force है ना? Work done by gravity. Gravitational force नीचे लग रहा है, lifting force ऊपर लग रहा है. If you have to draw a rough diagram, ऐसा है ना? So gravitational force mg is acting downwards, और जो lifting force F है, that is acting upwards. लेकिन ध्यान रखिए, शुरू में क्या बोला था? Moving with constant velocity. अच्छा, constant velocity कब होगा? V is not changing, right? Therefore, acceleration, that is dv by dt, will become 0. Therefore, the net force on the body, that is given to you by m into a, that is also equal to 0. Net force is equal to 0. अच्छा, इसका क्या मतलब है? देखिए, net force is equal to 0, meaning that the upward force is equal to downward force, right? So we can say that this F lift is actually equal to mg in magnitude. Please remember that. They are both equal in magnitude but acting in opposite directions. Okay, so remember, whenever I have not drawn that vector sign, I am only talking about the magnitude. Okay, coming back to the question, if you read the first one, na? Work done by lifting forces. Work done by lifting force. Okay, now how is the body moving? That's also written, moving vertically up, right? So if I have to show it like this, moving vertically up. Okay, so the work done by the lifting force, work done by the lifting force, what is it going to be? Pretty simple, na? This force multiplied by the distance it has moved upwards, right? So I can simply write it, F lift multiplied by the distance moved, let's say, is x, and this is positive, right? This force is also upwards, displacement is also upwards, so it is positive. Now what about work done by mg, the gravitational force? Work done by gravitational force, remember, gravitational force is acting downward, that body is moving upwards with, let's say, distance x, so work done will become, remember, work done is given by dot product of force into displacement, right? So mg vector dot of displacement vector, so it will actually become minus mg into x. Okay, minus mgx. I hope you understood why it is negative, right? Force and displacement are opposite. So if we come back to these options, work done by lifting force is positive, right? So A matches to Q. Work done by gravity, it is negative, so this matches to P. Total work done by all the forces. Now what about total work done? Right, so what about total work done? I can write over here, total work done is actually work done by this lift force, right, plus work done by mg. This will become, lift force is how much? F lift into x, while this is minus mgx, right? And this, my dear friends, they cancel each other, and therefore this becomes 0. I hope you understood. Why do they cancel each other? Because just here I have written F lift is equal to mg. If F lift is equal to mg, F lift x is equal to mgx. So they cancel each other. So total work done is going to be 0. So this matches to R. So A, B, C, Q, R, P. Q, R, P. Right? So first option is correct. Okay. Otherwise also you could have verified this and you could have found this to be 0, the total work done, right? How? because remember total work done by all forces using work energy theorem, we can say it is change in kinetic energy. But if velocity remains constant, there is no change in kinetic energy. So change in kinetic energy is 0, so total work done is also 0. So that way also we can say B matches to R. Okay. So first option, let's check, and yeah, first option is correct. Moving to question 42 now. It's a very straightforward question, this one. If you read statement A, this says, if a particle is outside a uniform spherical shell, the sphere attracts the particle as though the mass of the shell were concentrated at center of sphere. Okay, so remember a uniform spherical shell we are talking about, right? Uniform spherical, obviously I am not writing spherical because as shown in the diagram it is in the shape of a sphere. Okay, and where are we keeping the mass? Mass, remember particle is outside, right? The particle has been kept outside. This is, let's say, the particle of mass m, it has been kept outside. So obviously remember, if it is kept outside, there is going to be gravitational field on this mass, and remember that gravitational field is attractive, right? It is going to exert a force on this mass, right? If you want, let me draw this even further over here. That is pretty much nothing but the gravitational force, right? So the gravitational field is attractive, thereby the gravitational force exerted on this mass is also attractive, like this, and it is pointed towards the center of the spherical shell. Okay, and this is that force, attractive force F. Okay, and this we are saying, this is like, pretty much like this entire mass were concentrated at the center. Why so? Because remember, if this mass is capital M, right, and let's say this separation is D, so we can write this F as something. F is nothing but G capital M small m by D square, right? As in, this is pretty much nothing like a, or as in pretty much like a point mass situated at the center, capital M, separation is D, so force of attraction is this much. Okay, so it attracts, right? The sphere attracts the particle. So statement A is correct. All right. Statement B says, if a particle is outside a uniform spherical shell, that is the same diagram, the gravitational force on particle is non-zero. That is also true, right? Obviously, this is the gravitational force, and this is obviously non-zero. This is non-zero, right? So this is also correct. Now statement C says, if a particle is inside a homogeneous solid sphere, now we are changing the sphere, the gravitational force on the particle acts towards the center of the sphere. That is also correct. Remember, now we are talking about a homogeneous solid sphere, right? It's a solid sphere, and we have, let's say, kept this is the center, and let's say we have kept that particle over here. And now, let's say this is that distance D, okay, from the center. And this, remember the original radius, here also the original radius is capital R, and here also the original radius is capital R, and the mass is capital M for the whole solid sphere, right? And here also, remember this mass M is going to be attracted towards the center due to a force F, and that force F is due to a gravitational field G. Okay, so that gravitational field G is given to you by what? It is given to you by this formula, G capital M small d by R cube. Okay, this, remember, is the magnitude of that G, and that is directed inwards towards the center. So what about the force F on this one? That force is going to be directed towards the center, right? So that force F is going to be, let's call it G dash, if I may, that is equal to M into G dash. That would be equal to G small m capital M into D upon R cube. Okay, and that is, my dear friends, directed towards the center. Okay, I hope you got it. let's see the statement again, and yes, it's also saying it is directed towards the center, so yeah, this is also correct. So all three statements are correct, and therefore option 4 is going to be our answer. Okay, pretty straightforward this one. So I hope you got the explanations as well, huh? Okay, so let's move to question number 43 now. Question 43 says, and it's based on fluids now, the velocity of kerosene oil in a horizontal pipe, remember it is an horizontal pipe, right, is 2 meter per second. Yeah, it's 2 meter per second. So this we are calling it as V. If G equal to 10 meter per second square, then velocity head of coil will be. So velocity head. So now we are talking about 3 heads: pressure head, gravitational head, and velocity head. Okay, so remember the formula for energy per unit volume, that is we are writing the Bernoulli's theorem. Okay. So Bernoulli's theorem, if we write, right, that is P plus half rho V square plus rho GH equal to constant, right. This is the standard formula, energy per unit volume. But remember here we are talking about the velocity head. So what will be the pressure head? So remember, divide the whole expression by rho into G, that's all. Okay, so this expression will become pressure upon rho G plus, here if you see, divide by rho into G, rho will get cancelled, thereby leaving you with V square by 2G, and here this will become H equal to constant. But if you come back to the question again, they have said it is horizontal pipe, so there is no change in H, right, there is no change in H. So if you want, we can remove this as well, it plays no role whatsoever, right, because if that entire pipe has been arranged on the same horizontal level, the value of H will remain same at each and every point of the fluid in that horizontal pipe, right. So the velocity head over here, my dear friends, is this term, okay, and this, my dear friends, is pressure head, please remember, and this is velocity head. So velocity head is V square by 2G, that's all we have to calculate. So if we calculate over here, V square is how much? 2 into 2, that is 4, 2 into G, that is 2 into 10, 20, right, 4 by 2 is how much? 2, so 2 by 10, 0.2, and what will be the unit? In meters, right. Why in meters? Because remember each term has the same unit as H over here, so H has the unit meters, that's why. Okay, and if you want, you could have removed rho GH here also, because for horizontal pipe there is no need to write rho GH term. Okay, anyway, 0.2 meter is our answer. Let's check, and yeah, 0.2 meter is correct. Moving to the penultimate question of this exam, right. A simple pendulum has frequency f1, right. So simple pendulum, right, something like this, right, it's oscillating, frequency f1. If the point of suspension, that is this point, okay, this point is now moving upward with constant velocity, 2 meter per second, then frequency becomes f2, then f1 by f2 is. So remember they are saying obviously gravitational force is acting on this bob, right, and this point of suspension is now moving upward with velocity v. Okay. Now what about, before coming to frequency, what about the time period of the simple pendulum? Now what is that formula? Time period T is equal to 2 pi under root L by G, isn't it? And here the formula for G we are using is G effective. Okay. Now remember, if this were to move with an acceleration A, then with respect to this point of suspension, right, we would have got a pseudo force on this bob in the downward direction, that is m into A. Therefore that G effective would have become G plus A, right. Therefore the time period would have changed. But here, my dear friends, since they are saying the velocity is constant, therefore if velocity is constant, acceleration is equal to 0. Acceleration equal to 0, there is no pseudo force, that is the G effective will remain the same. G effective will remain as G only. Okay. G effective is equal to G in both cases, right? Therefore, those frequencies F1 and F2, they are also same. There is no change in time period, no change in frequency. Okay, so therefore F1 equal to F2, and therefore that ratio will become nothing but 1:1, that is 1. Okay. Yeah, so now moving to the final question of this exam. Answer to this one was 1 only. Okay, question 45. Question 45, let's see what this says. It says 2 moles of diatomic gas is mixed with 3 moles of monatomic gas in a container, right? And then the ratio of specific heats they are asking, that is Cp by Cv they are asking. Okay. Now for diatomic gas and monatomic gas, first define degree of freedom. What are they? Let me write down over here. Diatomic and monatomic, right? Degree of freedom, what are they? Remember, for monatomic we have 3 and for diatomic we have it as 5. Okay. Now for monatomic, the Cv, that is molar heat capacity at constant volume, right? Cv is given to you as FRT by 2, right? That is it's actually Fr by 2, rather becoming 3R by 2, right? So if you were to write the internal energy, you would write it NCVT. NCVT, that is N into 3R by 2 into T. Okay, and what about Cp? Cp is Cv plus R. So this will become 5R by 2. Okay. Now what about this one over here? You can write Cv. Cv once again, use that same formula, Fr by 2, thus becoming 5R by 2. And Cp is Cv plus R, therefore becoming 7R by 2. Okay. Now we have to find the ratio of specific heat for the whole mixture. So let's find Cp for the mixture, Cv for the mixture, and then divide them both. Right. So that is one way of doing it. So let's try it. So if we were to do Cv for the mixture, right, and remember the number of moles of each, 2 moles of diatomic, 3 moles of monatomic, right? 2 moles over here, 3 moles over here, right? So Cv mixture will be nothing but N1 Cv1 plus N2 Cv2 upon N1 plus N2. Okay, so if we solve 2 into 5R by 2, that is 5R plus 3 into 3R by 2, that is 9R by 2. Okay, then 2 plus 3, that is 5. Okay, 2 moles and 3 moles. So if you solve over here, what is this coming? Take LCM, 5 2s are 10, 10 plus 9, 19, right? So 19R by 10. This is coming as your Cv mixture. Okay, and similarly you can find the Cp mixture. Use that same formula, but in place of Cv we are going to use Cp, that's all. Right, so this is going to become 2 into Cp, that is 7R by 2. Right, so this becomes 7R, then 3 into Cp, that is 15R by 2, divided by 2 plus 3, that is equal to 5, right? And if you solve over here, this is going to come, 2 7s are 14, 14 plus 15 is going to be 29, right? 14 plus 15, 29, 29 by 10. right? So 29 R by 10. Okay. So 29 R by 10. So now we can write Cp by Cv for the whole mixture is actually Cp mixture by Cv mixture. Cp mixture is coming how much? 29 R by 10. Cv mixture is coming how much? 19 R by 10, right? 19 R by 10. Substitute it. Ten and 10 will get cancelled, right? R and R will also get cancelled, and therefore the final answer is coming 29 by 19. Okay, which is option number 3 over here. Okay, which is option number 3. Okay. There is also another way of solving the same question, right? That is, we find the gamma mixture, right? Gamma mixture using first finding gamma mixture is equal to 1 plus 2 by degree of freedom of that mixture. Okay, so that's another way, but this is also one way. Anyway, option 3, and let's check, and yeah, so option 3 is correct. Okay, so all right students, I think we are done for the day, right? So I hope you guys had a great time, and me as well, right? So until we meet next time, keep practicing and keep working hard. Thank you.